Hello and welcome everyone to another episode of the WeAreDevelopers Live Days. My name is Bene and I'm here at the headquarters of WeAreDevelopers in Vienna, and I'm happy that you all joined us today. So today is all about DevOps, but before we start with this topic, just a quick reminder for all of you that Code 100, our coding competition, is back. The next stop is Amsterdam on February 29th. So if you are in the region, make sure to check in and go to code100.dev after this event, of course, to get further information and to claim your tickets. So, and as a quick reminder for our regulars and as an info for our newcomers, during the talks, feel free to interact in the chat to your right. Submit some questions if you got any. The speakers will gladly answer them after the talk, but during these interactions, please be nice to each other and respect each other as we have a code of conduct. Here's a short video about it. And now let's kick off DevOps Day together with the first speaker. He is software engineer at RedCarbon SA, started coding at the tender age of 12. He loves Node.js, Golang, and Kubernetes, and also is a co-organizer of Schrödinger Head, which is a community, a developer community based in Italy. Very welcome, David.
Hello. Thank you, Benny, for the introduction.
Hi, David. Yeah, thank you so much for joining us today. So before we start with your talk, David, would you mind giving us some insights about your topic, about what we're going to learn from you today?
Yes, of course. The topic of today, my today talk, is about GitOps. Like the first talk I've made last year in this kind of event, but the focus now is on the secrets, because people don't know how to store secrets inside of Kubernetes, how to handle inside of a GitOps ecosystem. And I decided to do this talk by exploring the various opportunities that we may have to handle secrets in this kind of world that is disrupting right now in DevOps world.
Yeah, very good topic to start off the day, I would say. So without further ado, David, the stage is all yours.
Thank you. So I'm going to share the screen and the slides. Okay, the slides are fine. I don't see anything, so okay, perfect. Just a quick check. So, as I said, my talk today is about securing secrets in the GitOps era. And the subtitle is, how do not share your secrets in a Git repo, because it's not so good sharing secrets in a Git repo. I can say it's a pretty good point, and it's an important topic in the security nowadays. So, first of all, I want to introduce myself. I know Benedict has already introduced me, but I want to introduce myself too. I am Davide Imola. I'm a software engineer in RedCarbon, which is a Switzerland company that makes a software for handling security incidents through AI. And also, I am a community manager and event or co-organizer at Schrödinger, which is a community, an open source community. We have started doing things in Italy, and we made events like the Open Source Day. If you want to know something more about me or have other informations, you can go to the link down below, links.davideimola.dev, which is a sort of link tree where you can find my socials. You can schedule a call with me to talk about this topic or something else. My website and all the reference about the community that I manage. So, without further ado, I want to start talking about GitOps because I think it's important to start talking about GitOps because maybe not everybody knows about GitOps. What is GitOps? So, it's a way of managing the infrastructure and applications so the whole system is described declaratively and version controlled. So what I want to say is, for example, I have a Git repository because it starts from a Git repository where I put my my configuration Kubernetes file, for example, my deployment file, my service file, and I have an automated process of deployment inside of the cluster. So the cluster is taking from Git that is becoming the only source of truth. We are going to take the information from the Git repository, and we are applying all the things that are inside in this Git repository and applying it in the cluster. This is kind of sort of magic, I can say, because it's really cool when you start playing around with GitOps, because you are creating a file on a Git repository. In a few minutes, you have your app running in your cluster smoothly. So, what are the benefits of using GitOps? Of course, the first benefit is managing the infrastructure and the app lifecycle within a single tool, because it's simple as that. Within within GitOps, our GitOps tool, we can not only create infrastructure, so maybe Elasticsearch infrastructure, NATs, or queues, or stuff like that, but also we can handle our application lifecycle. So we can handle updates, we can handle rolling updates. So, for example, if we want to do something like blue-green deployment, canary deployment, and stuff like that, we are the cool thing about GitOps is that we are checking directly our image repository, for example, our Docker registry, and checking new images, and GitOps is automatically updating those images in the cluster too. Of course, I can say we have faster deployments, because if we are doing this thing and we have an automated process that automate the deploys are faster, because we are not we have not to go inside the cluster and change its configurations, because there is a robot that do this thing for us. And as I can say, is the best thing, because there is always a problem in all the development pipeline, and it's always between the chair and the monitor. So if we are doing this thing through a computer, maybe it's better. And of course, it helps the DevOps adoption of an organization, because GitOps is helping the DevOps adoption, because you have the capability to work on the cluster without then having the direct access to the cluster. You might have simple your access on the GitHub repository. You're doing stuff on the GitHub repository. Is a tool that is easily used by all the developers out there, Git. And we are making simple pull requests, committing the changes on a branch, and all the things is handled by another thing. So of course it helps the DevOps adoption. Those two are two of the main projects that when we are talking about GitOps. The one on the left is Flux, the arrow, and the second, the orange logo, is Argo CD. I can't say which is the best. They suits you all the different way, because they do the exact same thing in two different methods. But it's not important if you choose Flux or Argo. It's a matter of your choice. It depends on what you want to do, or in what do you prefer. For the talk of today, we are going to use Flux, because I am more proficient with Flux than Argo CD. So let's start talking about this. As I say, we have a Git repository. We have a Git repository with our deployment. The deployment is my super fantastic app, which is always a super fantastic app because I have developed it. And we have the deployment. But one day, the team says we have to insert a database. Because, of course, probably we have to store this data in some way, because I think maybe we have to store some data. Of course, the database have one thing in common, which is the super secret password, which is 12345678990. Please don't store this password, because it's the password of production database. I'm joking. And of course, if you want to store the secret, because if you know how to use Kubernetes, you know that you have the secrets. The secrets, you create a secret file inside the Git repository, which is a kind secret with our super security password. Okay, of course, on the deployment, you may reference the secret, and we are just fine, because we have the secret, we have the deployment that references the secret, we can access the database. But you have to think about one thing, that in the meantime, the security team, you may not have a security team, but imagine that you have a security team, are something like that. It's strange, because I've done this talk in Italy, in a conference in Italy, in Italian, of course, and with all the people, and they start laughing. Now I'm all alone and no one is laughing. It's a bit strange, but it's fine. So what's the problem right here? Is that we are not considering one important thing inside of our picture. Is this one, which is a famous Italian hacker. No, I'm joking. It's an Italian meme that where this Mickey Mouse that is an hacker, and It's an Italian meme. I have no more to say, but I like it because it's Mickey Mouse as an hacker. So we have this hacker, and some security analyst says that if the hacker has access to the Git repository, 100% of time the password is hacked. Why? Because in the secret, the value of the secret, this one, I can't point it, but perfect, is only a base 64 encode of the password. So if an hacker has access to this value, it simply may do a base 64 decode from their terminal, and they have the real value, and they may have your real DB password. So of course, it's not something that is cool enough, because of course you can understand, I can access my Git repository and I have my password. It's not a secret anymore. So maybe a set developer said, I can't manage my KOS keep secrets inside of Git, because if I put it on Git, my value is plain. It's not plain, but if you do base 64 decode, it's plain. Okay, it's a huge opinion, but what I can say is yes, we can. And now I'm Obama. Perfect. Yes, we can, because we have meted to handle this thing inside of our GitOps pipeline. The first option that we have is CL secrets. CL secrets is a cool thing. It's an operator, a Kubernetes operator, which is running inside your Kubernetes cluster. It works through use of a public and private key to encrypt and decrypt your secrets. So, for example, you can gain from Kubernetes your public key. You can encrypt your password, your secret, with this public key and publish it on Git, because it is encrypted. And of course, if you know something about public and private key encryption, decryption, if we encrypt something with the public key, we need our private key to decrypt our secrets. Of course, the private key is only known as to Kubernetes. Kubernetes is the only one that knows this private key. So only Kubernetes cluster is able to decrypt the secrets. This thing is usually accessed and used from other Kubernetes objects, like normal streams. Because if we put this sealed secret, the operator is doing something that is taking the sealed secret, is decrypting it, and creating a secret inside of Kubernetes. So we do not have to change anything on our side, because the applications works exactly in the same thing, in the same methods, because we still have a secret object at the end of our story. Of course, the cool thing about this is that the public key can be stored inside your Git repository, because the public key is not a secret. You can store this key. So please raise your hand. I don't know if you're doing it, because I can see you, but it's now time of a demo. So hi to the demo god, to assist me, hoping that everything may go as expected, or maybe I can do some jokes to entertain you all, because maybe it's something that is not working. So we are here in our Visual Studio Code tool. As you can see, we have a simple installation of Flux. So we have already Flux running locally. As I can say, I can show you my K9S if it's starting. Okay, perfect. So if you're going to go to the secrets, we can see that we have a secret, my secret, and I've already stored it as a normal secret. So now we have this thing. Sorry, we have this thing. Okay, this is our secret, the normal secret. Of course, as I can say, if I take this data and I'm doing this, and I'm going to do an echo pipe base 64, this one, you can see that something is not good, because we have in our Git repository a value that by doing this thing, we have the right value. And of course, it's not a good thing, because if an attacker has access to your Git repository, may know your secret. So first of all, we have installed. I have already installed the operator, the Bitnami sealed secret operator through Helm. It's simple as that. We are adding a repository, and after that we are creating a release of the CL secrets, and just like this, everything is working. Is something easy. It's easy to let's start digging with sealed secrets. So let's start talking about. Let's start deleting this one, because I don't need it. Perfect. So let's start talking about how we can encrypt these secrets through the sealed secret key that you may have installed as I don't remember how it's called. A kubectl is a key that is used to operate through with the sealed secrets. So you may install this key. Through the key, you can download. You may have access. You must have access to your cluster. First of all, you may download your public key, which I have already stored inside of my Git repository. This one is a public key, so I can show you how. That's simple as that. And we can use this key to seal the secret. To seal the secret, we can use this command, which is kubectl path to the certificate, to the PAM file. We are going to specify that the file is a YAML, and we are going to say this thing, and it says, okay, ingest the secret file, which is this one that we have already, this one, and please put it out in secret sealed. So here we go. We can take this thing, paste it, and okay, let's see what is changing. Okay, now we have this file. automatically something has been created inside of our repository, which is a file, which is a sealed secret customer's resource definition, and is an encrypted data. We have our secret foo and the value. The value, as you can see, is completely different from this one. And if we are taking this thing, okay, and we are copying it. If I want to do this thing, I can show you that we cannot decode anymore our secrets because it's encrypted through the key, through the PAN file, with the PAN file. So it's good because this thing, we can store these sealed secrets in our repository because we do not have anymore a security issue when pushing these things to get to our remote repository. So our application, I have an application. The application is currently accessing our secret, and I can show you this thing by going to the deployments. Maybe I'm okay, better. There is our, let me change a little bit because, okay. Zooming out. Okay, K9S, we have the deployments. The deployments is accessing, if I describe, is accessing the secret key foo in my secret. So what I want to do, is to show you that if we are going to delete this secret, which is the secret that has the...
David, sorry to interrupt you just real quick. Could you please zoom in a bit on the editor?
Zoom in?
So, yes, please.
Okay.
Just a little bit. Yes, I think it's much better now. Thank you so much. See you after the talk.
See you after. So, sorry about that. There is our sealed secret, which is the secret without the... We are not having the basis 64 value anymore. We are simply using customization for this thing. Simply, I want to say that, okay, no more secret, but use secret sealed, because we want to import in our customization the secret seal file. So as simple as that, we are going to push the thing inside of our repository. So git add, git commit, okay, fit, we are devs, and pushing it. Okay, pushed. Everything has been pushed. Let's see if something is created. Maybe I can forcing just to not attend so much time about the reconciliation of Flux, because Flux has a polling where that is possible to set that say, okay, each 5 minutes, each 1 minute, I'm checking the Git repository. As I do not have all the morning waiting for the reconciliation to run automatically, I forced it with this command, which is Flux reconcile customization Flux system. So perfect. As you can see, now we have an object. Maybe I need to zoom in a little bit. And okay, this is our sealed secret. We have a sealed secret now. We can see it if you want. Is the thing that we have already seen it in Visual Studio Code. There is the value, there is all the things that we need, and stuff like that. If you are going to see the secrets, my secrets is also created. As you remember, I have deleted it from our repository as I don't need it anymore. So this thing is called 57 seconds. It has an age of 57 seconds, like more or less the seal secret. The seal secrets, of course, it has much age because there is a process that is creating those secrets. So now we have this secret. And of course, this secret, you can see the value, which is bar. And now we can do whatever we want because we have these secrets. And of course, the application is working just fine because the application can reach this secret. It's always there. It's simply, we are not handling from our Git repository, but it's handled by seal secret. Of course, we can do an echo of the variable. I don't remember how I call it. Silly me that I don't. It's my secret foo. How I cannot remember it. Okay, my secret foo. And as you can see, we have our secret inside of our application, our pod. And this secret is created through CL secrets. So now we do not have any security issue so far. Of course, there is always a security issue because in the past I have put the file with the base64, the code. We have to change all the Git history to remove the commit, but it's not something that is important to us right now. So the demo is gone away. Everything is working. So go. Let's talk about the pros and cons about working with sorry about that, about working with CL secrets. The pros is that are easy to use and to configure. As you may seen in the demo, the use of sealed secrets is pretty easy. You must install an Helm repository, and you're ready to go. You can create a file, a YAML secret file, encrypt it, and push it to the repository, and everything is working. Because the other point is that seal secrets works like a normal Kubernetes secrets. Is not something that is completely different because we always have a Kubernetes secrets at the end. Of course, another pro is that the secrets are stored inside of Git. So we are doing the real GitOps because the secrets are in Git. The cons is not so fast to change the value of a secret because you have to open it up, create a new secret file with the base64, the code of the value of the secret, and sealing it and push it to the repository. Of course, it's not so difficult, but of course you have to do different operations to achieve the change. It's not something like going to a dashboard and change the value and saving. No, it's not like easy as that. And of course, it's not so easy to retrieve the history of a secret because, okay, we have it on our GitHub repository, we have all the secrets, all the history of the secret, but is encrypted. So it's not easy to ask to Kubernetes to decrypt the secret. We can do it in various ways. I don't want to say here to explain how to do it, but of course, as you can see, we are not a version that is okay. Show me the value. Okay, the value was 10 days ago was full, and now is bar. It's something that we have to operate. So another thing that I want to talk about, also apart from sealed secrets, is the using of a secret manager. Secret manager are softwares that we can install in our cluster or use some sort of managed secret manager, and are tool that helps us to handle our secrets in within a tool. They can be self-hosted and open source, like HashiCorp Vault, that now has some problem with the change of the licenses, stuff like that. So now we have a fork, which is OpenBow, which is a fork of HashiCorp Vault, or any cloud-managed solution like Vault Cloud, AWS Secret Manager, the one from Google or Azure, and stuff like that. Of course, the managing of a secret is simplified thanks to the web UI, because we can access a web UI, we can show the versions of a variable, understand when it was created, and we can show the values on the history. Of course, if you are using the managed solution, so through a cloud provider or through Vault Cloud, no infrastructure is required, because the infrastructure is required not in the cluster but in the cloud provider. So what are the pros and cons about working with Secret Manager? The pros are web application where to handle your secret, to change them whenever you want. It's easy as that. You have a web application, you can access the web application, see all the secrets, and change them, view the value, view the history, and stuff like that. It's very easy. Of course, we have a pro. We can talk about it pro. We have a database of secrets. It's saved or in a managed solution, or simply, for example, for Vault, inside your cluster. So it's not going anywhere, your secrets. They are not in Git. It's not so much GitOps, but we are talking about it later. Of course, the possibility to scale up is much easier, because if you're using a managed solution, the managed solution always scale up automatically, and you don't need to do anything. And the most cool thing, and that is not so easy to do with sealed secrets, is operate rotations, key rotations. For example, if I have a database, the perfect thing is to continuously change your secret, your DB password, just to avoid that someone may have access to your password and access the database always. So we are giving away this capability to the attackers by continuously change the password. Cons, of course, there is the cost, because of course, if you're going to go for a managed solution, you have to pay for a cloud provider, the cost of the cloud provider, or the cost of the infrastructure if you're hosting it in your cluster, because it's, of course, much more heavy than the sealed secret thing. And of course, the management. The management is a little bit more difficult because are more complex applications. They have more management if you want to install it in your cluster, also in the cloud, because you have to work with how to access them through your application. But how to access those data from a secrets manager? The first thing is instructing your application by using SDKs. So you must change your code to access those secret manager and access the secrets that you want. Vault or the other cloud provider made a lot of the SDKs for all the different programming languages, so you may choose to go for this part. And instructing your application is something that is cool enough, because you can do very much more things that the other solutions, because you can handle, for example, seeking for changes in your values of the secret and stuff like that, and you don't need to restart the application, for example. Another thing that is currently used and very widely used are the secret store CSC drivers, which are some part of drivers that you install in Kubernetes. You instruct those drivers to access your secret manager secrets, and they create you a secret inside the Kubernetes. This thing, as I can say, is the most GitOps way to handle a secret manager, because you are creating a Kubernetes object that creates other secrets. And of course, there are plenty more possible solutions that are given by the secret manager. So there is no, for example, Vault, there are operators to handle the secrets and stuff like that. If you are interested more about this thing, I have wrote a blog post in the past in my blog, which is about sealing secrets in the GitOps era, where I decided to go more deep inside of this thing. So if you are interested in digging more about these possible solutions, feel free to read the blog post or just give me a ping, and I'm very happy to start talking with you. Last but not least, as I say, I am a part of Schrödinger, which is a community, an open source community. And in March, the 7th and 8th March, we are doing the third edition of the Open Source Day, which is a conference about open source. So we are talking about open source projects and stuff like that. This time is a 2 days conferences with a lot of speakers, a lot of interesting speakers, and a lot of interesting talks. So the venue is in Florence, in Italy. So if you want to reach out, we are in Florence at Nana Bianca. But also we are doing a live stream event on YouTube where we can put all the talks in live when they are talking. So through the QR code, you can go to the site, or I don't remember if it is the site or the tickets, but through the site you can go and check for all the information that you need. And with this thing, I like to say goodbye and so long. And thanks for all the fish. And this is all for today for my talk. And just a reminder, links.davideimola.dev if you want to start looking at me. And Benedict, if you want.
Yeah, David, hello again. Thanks for the talk. Thanks for the many references. I especially loved the office meme.
Perfect.
So, and we still got some minutes left. So, what would you say if we start in a Q&A right away?
Yes.
Yes. First question, pretty straightforward. Please share your GitHub. We searched for it and we posted it in the private chat. Could you just confirm that this really is yours? Then we would share it with the audience. Yes. Okay, that's enough. Yes, we'll take that.
Yeah.
All right. Thank you. Next question. Do you use different public or private key pairs for each project to encrypt and decrypt secrets?
No, I just use an only sealed secrets instance, and because the most important thing is you store only an instance of sealed secrets, and you have the private and the public key. Of course, the public key is only one. I don't see the good thing to have more keys, because it may become a lot more complicated to handle all the things, because you must remember that this project is using this key, and the other project is using the other key. We have only one key, and the key is used to create the secret.
All right. Thank you, David. Let's go on to the next question. How do you ensure secure transmission of secrets from the secrets management solution to Kubernetes clusters?
Okay. This thing is done through. It depends, first of all, where you put your secret management solution. Because if it's on-premise on our cluster, you are making on-premise and private. So you are not giving public access to your Vault instance or stuff like that. But also this applies to the cloud thing. For example, if you are creating an AWS secret manager to handle the keys, you may change the policies on how the people can and the application can access this secret manager. So you can restrict the access to the secrets. Of course, also secrets in the web UI can be restricted through a login. So you can create policy of access. So for users and also apps. So apps can view only a part of the secrets that we have, and not all of them, because it's not the application is not needed to view all the secrets, but only a little part of it. And also the users. For example, I have a team, the development team. I want to that they can view only the development secrets and not also the production secrets.
Yeah. Makes sense. Thank you so much for answering this question as well, David. And we got another question. How are secrets managed in a multi-tenant Kubernetes environment?
Okay, I'm not so skilled in multi-tenancy. I have never used tools like Class. I tried it, but it's not something that I'm currently using. Like Classics or Istio, I think. But it's it's like you're handling your, as I can say, your applications, because there are always objects inside your cluster. So if you're going to specify some information, for example, the namespace, let's talk in much easier way with namespaces, we can create secrets that are sealed secrets that are pushed in a specific namespace and not in another namespace. And this is a sort of multi-tenant environment.
Right. Thank you, David. Next question. Do you prefer one secret tool solution more than the other? Do you use various secret tools on projects like HashiCorp Vault, AWS Secret Manager, Azure Key Vault, or something entirely different?
Okay. Let's start talking about that. We have started working with sealed secrets. Now we are going to HashiCorp Vault, but Vault has the problem with the licenses. Now we have to understand what to do right now. But as I can say, I prefer to keep the secret in one place rather in different places, because it may become more difficult to remember, okay, this secrets where the secrets is right now is on Vault, is on AWS, is on Azure. Of course, having only one spot, it's less secure, but not so much, because of course it's something that they care more about, because they are companies that works in security. So I think they want that your secrets are secured enough.
Yes. Thank you for this answer as well. And we jump to the next question. What's the best practice to ensure that secrets are securely disposed of when they are no longer needed?
I don't have an answer for this one, because it's not so easy to say when a secret is not more needed, no, it's no longer needed, because we can't see if a tool is actually used or not. It's a matter of cleaning phase, and when you're working up more with it and you see, okay, this thing is no more used, okay, we can erase it from our repository or from our secrets manager. And of course you have to perhaps there are I don't know if there is any tool that make this check and see if the last use time of the secret. Perhaps it may be a possible solution to understand if there is something like that.
Thank you. Next one. How do you manage secrets for non-Kubernetes resources in a GitOps workflow, like database or VMS?
As I can understand from the question, is if I have a database that is not inside Kubernetes, how I can share it. As I can say, if you create, for example, a database and you are creating a value, you can use the password and save it in a secret manager. It's not required to use it and save it in another place. It's like a one password or something like that. Is a key value, so you're saving all the thing inside your. It's a database of key and passwords, so you can use it. You can save whatever you want, and you can access from whatever you want. Of course, I don't know if the database has to retrieve the password I don't think it's possible. Maybe if you're doing some sort of plugins for the database, but not so easy to do it. But a password can be saved simply, and you can use it from wherever you want.
Thank you. Next question. Do you have some tips on managing secrets used by third-party applications or services running with Kubernetes clusters?
Used by third-party application. Running with Kubernetes, I can say, if you want, you can use your secrets. You can create the secrets from a sealed secret if you need it. And this is creating a secret. Of course, it depends on the application, I can say, and the configuration that can accept. Actually, I can know which application is. I don't know the context, so I can't answer exactly all the things. But as I can say, it's something that you can extract by passing it through. The secrets can be passed through environment variables, so it's something that may work. Also, if you're using a secret manager with the CSI driver, you're creating a secret, and the secret can be used as an environment variable inside the application.
Right. Thank you for this answer as well. We jump to the next question. Maybe an outlook. Do you know what comes next? Any ongoing developments or trends in the field of secrets management within GitOps ecosystems?
Currently, secrets management in the GitOps ecosystem, there is not so much development right now. The only development that I can say is that currently there is this new project, which is OpenBow, that is burning right now, which is a replacement of HashiCorp Vault. Because if you don't know, Vault as the HashiCorp decides to change all their software solutions, their licensing, and making this licensing more restricting on the use cases, the free use cases, instead of earlier that is everything was open source and you can use for whatever you want. Now you have to check if your use case is fine for their policies. And of course, this thing is not so much liked to the open source community, and they start working with this OpenBow, which is a replacement. But there is no more trends on the field of secrets management. There are many trends in the GitOps, but different trends, but it's something like that.
All right, thank you. We got another question. How do you tackle the issue of secret sprawl across a large-scale Kubernetes deployment?
It depends. It's difficult. It's a difficult question because I didn't take this issue right now because currently I'm working in a more restrict area, so I can handle it much simpler. So I really can't answer this. I really don't know. It depends on the use case, on all the thing that is currently working inside your Kubernetes, because of course it's not so easy. It depends.
David, it depends is an answer I get lots of times at live. And I think it is just the case with lots of things. Yeah, so many different use cases. So it depends is a very valid answer. Thank you for that, David.
No problem.
Let's tackle another one. What's a good way to do the integration of secrets management solutions with CICD pipelines in a GitOps workflow?
Okay. Let's start talking that it depends what you have to do on your continuous integration, continuous delivery pipeline. Because in a GitOps workflow, okay, you need the pipeline for the application that push your code to the registry. So you may have access to the registry, so you can handle the secrets by accessing it from various way. But the GitOps workflow doesn't need the continuous integration and continuous delivery in the Kubernetes part, because as it works, the orchestrator of the GitOps pipeline is inside the cluster, and the cluster has access to the Git repository. So we don't need a continuous integration, continuous delivery, which is the best thing, because the continuous delivery, the CI/CD pipeline doesn't know anything about your Kubernetes cluster or your production cluster. The things is handled automatically from the cluster. So we are not creating some sort of strange access through the cluster, through our pipeline to the cluster. But of course, you can handle the secrets in many ways by creating variables and stuff like that if you want in the CICD.
Right, David, thank you. I would say let's tackle one last question real quick, as I think it's very good one. How do you handle scenarios where different components of an application require different levels of access to secrets?
Okay, interesting scenario. Different components. Different components, as I can understand, is that we have an application with different deployments, I think. I use the most easier way. I talk about HashiCorp Vault. The authentication and the access of secrets is made from policies, and it sees, for example, the application as some sort of service account. You can add the service account to your application. Through the service account, you can say, okay, let's have the access to not only this resource, but also the other resources. So you are making a policy about your Kubernetes service account, because you may have the capability to log in through Kubernetes authentication. So you're using service account, Kubernetes service account.
All right, David, thank you so much for the Q&A, and thank you so much for this awesome first talk. What a way to start the DevOps day. Was very cool to have you again, and I hope to see you again on the next DevOps Live Day. David, have a nice day.
Have a nice day, Ben. Bye. Thank you.
Thanks. All right, and we jump to the next speaker of the day. He's head of DevOps at Permitio. He's passionate about development tools and open source. And as he loves sharing his insights and experiences, he's also a frequent speaker at tech events such as ours today. Very welcome, Ras.
Hey, everyone.
Hello,
how are you?
Thank you so much for joining. I'm fine. Thank you for asking. I hope you're too.
Yeah, I'm doing good.
Yeah. Awesome. So, Ras, before we jump into your talk, would you mind giving us 1 or 2 words about your topic?
Yeah, so the previous talk from David was actually very practical, I think, about secrets and how to handle this in Kubernetes. But in this talk, I'm going to talk mostly about the futuristic ideas of how the DevOps world will look like when the AI wave is coming into our beach, let's say. And I'm going to talk about best practices, about tools of AI integrated into the DevOps world. And at the end, I'm going to talk about how the day of a DevOps engineer will look like at 2030.
Oh, okay. Yeah, very future-oriented talk. I myself am looking very much forward to it. And I would say, without stealing any more of the time, Ras, the stage is all yours.
Thank you. Yeah, so I guess you can see my slides, right? Great. So, hey, everyone, again, my name is Cohen. I am an head of DevOps at Permit.io. And like I said before, today we are going to talk about how we can navigate through the AI wave in the DevOps world. So, right again, hey, everyone. I'm super excited to be here at WeAreDevelopers. Although it's a live, it's like a kind of a Zoom meeting. I would I'm really excited to actually come to the WeAreDevelopers World Congress, and I really looking into it. But for now, I think we have an amazing platform to talk about DevOps, as they really organize this DevOps Day, and I hope you will all have fun with me today. So let's start. Just a quick note: most of the images here are generated by DALL-E, and they are amazing. But some of the words that it generated are quite funny, so you can laugh if you want. But let's start with a kind of an easy story about the evolution of DevOps. So really imagine a world where DevOps, software delivery, was like a kind of a creaky bridge that connected two sides of the cliffs, right? The one side was obviously the developers. They are kind of disconnected from reality, or in our case, disconnected from production. And these developers really happily developing their product. Eventually, they wanted this product, this application, to release to production, right? So they were just throwing the code to the other side of the bridge, and on the other side of the bridge, there were the operation teams. So the operation team needed to get this code and release it to production. And unfortunately, this slow and full of error process was really generating many traffic jams. If we look at the metaphor of bridges, these traffic jams made all of the software development cycles really slow and very unsafe. And this was the pre-DevOps era, if we can look at this this way. And this process led into many inefficiencies and frustration. And fortunately, we were entering at the end of 2000s, kind of. We were entering the age of DevOps, we would say. And the DevOps was kind of a revolutionary movement that really started to gain velocity, as I said, in the end of the 2000s. And you can think of the DevOps as kind of a construction of a new bridge, more robust bridge that basically designed in collaboration in mind. And it was allowing of kind of a seamless flow from one side to the other, from development to the operation. And the goal was essentially to unify software development. So dev team on the one side and operation team from the other side. And it was all about ensuring faster and more reliable, and obviously continuous delivery of real high quality software. So as we look into the evolution of DevOps, we can segment it to many phases or segments, and each segment really contributed a lot to what we have today, to the robust and kind of dynamic bridge that we have today. And I think this image is amazing because it really shows how we started from this wood creaky bridge and went into this super highway kind of road. So let's start with the first segment. The first segment was really, again, in the late 2000s, it was really focused on collaboration. And all of the IT professionals that were in the companies back then were really started to understand that communication is the basis and the fundamental for improving the delivery process. And we can think about this phase, this first phase, as kind of the fundamentals of the better bridge, kind of the really first road or the first bridge to really for the future of the DevOps. And then we can talk about the second phase. And the second phase is really kind of building the infrastructure. At the early of 2010, the concept of DevOps really gained a lot of traction. And as soon as it really happened, many tools and also best practices began to emerge. And this was basically, if we can talk about it, it was like CICD really became the pillars of DevOps. So back then, we can think about this era as the creation of automation in bridges. So think about enabling cars, or in our case, code, to actually move faster from one side to the other side, and not only move faster, but move much more safely. And to ensure that code is really getting deployed to production more automatically, but also much more safely. And the third segment that I'm going to talk about is really the last 10 years, I think. And it's really the later eras that really introducing much more robust and fine-grained kind of infrastructures and tools. And there were a lot of terms generated back then, terms like infra as code and self-healing systems, major scale handling, and obviously robust monitoring systems. And this phase kind of wrapped up what we have today. And we can really look at the evolution of DevOps as kind of a story of transforming from, like I said, an old creaky bridge to a really super highway, seamlessly connecting the world of development and operations. And that's we are here today. And as we look to the future, I am super excited because there are much more, many things that are going to happen. And that's what we are talking about right now. And the next thing is basically AI integrated into the DevOps world, and that's what we are going to talk about today. So, hey everyone, again, I'm Cohen. I'm an entrepreneur from Israel. I'm 26 years old. I'm a wave surfer and a bass player. That's kind of fun. I'm really passionate about traveling and food. And I have 80 years of experience in all about development, DevOps, platform engineering, and I'm looking for much more, and maybe AI in the future. And today I'm actually helping developers to not build broken access control at permit.io. And just a quick recap about Permit. What we are doing at Permit, we are building kind of a full stack authorization platform to enable our developers, or in our case, our customers, to not build access control once again. And this was a quick recap about Permit. And let's jump off to our story. So, like in every company, every organization, doesn't matter if it's a startup or it's a big corporation, we all have kind of the same goal, right? Doesn't matter if you are the DevOps team or you are part of the development team, maybe the product team. You all want to kind of release to the live, to the real air, an amazing application, right? You have an idea, or someone has an idea, and you want to develop it and eventually release it to production. So in order to do it, obviously, we need to develop the code. But after this, we need to release it to production. So for this, we have Ross. So meet Ross. Ross is an amazing DevOps engineer. Again, Dali made this amazing picture. It's kind of a really cartoonish character. And Ross is super excited to really start this amazing journey of building the infrastructure. Fortunately for us, he really can do everything. He can start from the beginning. He can take open sources and tools, but he can do whatever he needs to actually release this application to production. And like you all know, this is the software development lifecycle, right? We all know, we all saw this many times, and we have tons of steps that we need to consider when we build our infrastructure. Starts with the basic. So it starts with planning, then coding, and after this, you need to understand how you continuous integrationing your code and then continuous delivering your code, monitoring, operating. You have many things that you need to do. And obviously, you have much more things than what I said right now. And it's really known for all of us, right? We all know this picture of like this flow of what we have to do, and we are talking about this for really years. But as a DevOps engineer, you have really many things to do, and sometimes it's not that easy, right? It doesn't matter if you are alone or you have a team of DevOps engineers or you are part of the development team. You really have to do many things, and you not only have to do them, you need to do it perfectly, because you need to make sure that the code will release the production, but also be perfectly secured, be perfectly monitored. If there is something or an incident, you need to alert everything, right? So things are really getting complicated. And not only this, uh, unfortunately for Ross, it's kind of hard, because in the modern world of development and infrastructure, you have so many more challenges. Buzzwords like IoT and quantum computing and big data are really getting much more attention in the latest years. And these words are really bringing tons of new challenges, and we need to understand really how to handle everything. Not only the operations, not only monitoring, not only alerting. You need to understand how you deploy kind of a big data or huge warehouse into your infrastructure, how you maintain IoT devices around the network. It's really getting kind of a mess, kind of a chaos, and really Ross has many things to learn. So the next thing that Ross will do, you can guess it right, Ross will quit. But no, I'm joking. Ross will not quit. It's just a really cute picture that I really wanted to put here. But yeah, Ross will not quit. Ross will handle everything, and I'm sure that Ross will understand what he needs to do first. He will prioritize the needs. But today we will understand how Ross can leverage the power of AI to really make his life easier, to actually take all of the things that he needs to do, stuff like monitoring, stuff like CICD and security, and he can leverage the power of AI to make his life much more easier. So today we're going to talk about the benefits of AI integrated into DevOps, the best practices, and some known tools that actually, again, make his life easier. So we will start by talking about the benefits of using AI in DevOps. And we can start with increased efficiency and velocity of development and software delivery lifecycle. That's really makes sense, right? And moving forward, we have improved accuracy and consistency. If you think about it, the AI agents or tools are basically need one thing. They need either a prompt or a good configuration. And by these instructions, you can really make everything really consistent. So we'll talk about it later, how we can use the tools to make our life easier, but they can really keep consistency and make our CI/CD, for example, much more consistent. And also the amount of data that we have in today's infrastructure, stuff like the amount of data that we have in our cloud, right? We have tons of logs, we have a huge amount of components in our cloud, and also we have huge databases. We have so many components and resources to actually understand, and using the AI, we can actually manage better the resources in our infrastructure. So we can use this for a better resource management. And obviously, like we all think about, AI really can benefit for us in the security world. So using a good tool that we can configure correctly, we can prevent misconfiguration and maybe vulnerabilities in our code and in our infrastructure. So this really is the kind of the benefits of AI when using it in DevOps. And let's dig down into the topics that we are going to talk about in the infrastructure. So we'll start by CI/CD. And the CICD is kind of the backbone of modern DevOps, right? Enabling us really fast and automated and obviously reliable software release cycles. And we can talk about code commits, merges, static scannings, building our images and testing our code. And really by integrating AI into the CI/CD pipelines, our team can really leverage kind of predictive analytics, because AI can catch all of the data that we obviously output and the CI/CD outputs, and it can basically catch failures before it's even getting to deploy to production. So it's not only accelerates the development process, it's also ensuring that the software releases meet the highest quality standards that we have or we want to have in our company. And for example, we have tools like Circle CI Insights that use machine learning to actually analyze your pipeline data. And it not only analyzes and gives you some feedback, it can also offer you some actions to really efficiency, to improve efficiency and also reduce build failures. So it's really nice. About GitHub Copilot, which is the top icon, I think you all must have heard about GitHub Copilot. But if you think about GitHub Copilot is not only helping developers and basically helping developers to develop the right code and maybe more consistent code, it can also help the DevOps team to write better CI/CD and better infrastructure as code, right? And at the last, we have DiffBlue. DiffBlue is an amazing example because DiffBlue provide kind of an automatic way to write unit tests for your code. So it's really nice to take a look at their product. The next thing will be infra as code. So we all know Terraform. We might know also Pulumi. I really love Pulumi. So you must take a look at their project. But basically, infrastructure as code really revolutionized our infrastructure and how we see infrastructure today, and how we manage infrastructure today. So how it really revolutionized it, it's basically treating our infrastructure as code, right? As a software. So now code can be versioned, it can be tested, it can be deployed much easier. And integrating AI into your infrastructure as code really enhances it and enabling kind of dynamic infrastructure provisioning. And that means that based on metrics and based on your application needs, you can really predict what your infrastructure needs and maybe automatic provision more resources or provision more CPU and memory, for example. And it's really it can be really beneficial to ensure that resources are really efficiently used and also getting adapted in real time and in the future. So in the right side we have Terraform. That when Terraform is combined with AI-driven insight, it can help not only make the visibility and management of the infrastructure resources much easier. It can also help us to automate provisioning of infrastructure and reducing manual effort. So we don't need now human hands, for example, to really understand what we should upgrade or what we should adapt. It can also prevent some potential human error, and also it can lead to much more stable and cost-effective infrastructure. So it's really nice to see. And also we have Pulumi. So Pulumi offers, it's actually free, so you might want to take a look at this. Pulumi offers kind of an AI code generator that can produce for you resources really directly into your code based on the prompt that you input to their chat. So that's really nice, and it's really nice to have a look at this. The next topic is FinOps. So FinOps today is kind of a really emerging topic, and it's really important mostly for big corporation where their cloud spend is huge, but also for startups that needs to really save money, right? So FinOps really enabled the team to balance speed, cost, and quality, obviously, and it's really based on metrics and usage. So in today's FinOps and AI solution, AI plays really a crucial role by analyzing the spending patterns. It can also predict future costs and also identify kind of optimization opportunities that you might want to take. And this could mean suggesting changes to maybe change the reserve instances that you have, or maybe suggesting underutilized resources to remove or to downsize. So it's really important. And also tools like Google Cloud. So Google Cloud has kind of a recommender, that's how they call it, and it provides kind of a AI-powered insights to your cloud to make smarter decisions about resource usage and really ensuring that your company getting the most of the out of the cloud without overspending. So it's really nice. And you have also FinOut, which is a company I really like. FinOut gives you kind of a real-time anomaly detection about anomalies that you have in your spend, in your cloud, or other services, maybe in Kubernetes. So it's really nice to take a look at this. The next topic is security and compliance. And in the world of security and compliance, AI really transform the way to detect and respond to vulnerabilities. So you have many topics in security, obviously, and you have continuous security, you have threat detection and response, you have vulnerability management, anomaly detection, and AI-driven tools can really prioritize risk based on the potential impact. So think about you have a set of vulnerabilities that are found in your system, and now you need to understand how to prioritize this, right? But everything is really dynamic because sometimes you have like a CV or a vulnerability that is really in high risk, but maybe something is in a higher priority because you have kind of a public endpoint for this service and you need to handle it as fast as you can, right? So using AI and really drive the AI inside the security world, you can really prioritize risk much better, again, based on the potential impact, and really ensure that your team focus on the most critical issues first. So we can take, for example, Aqua Security's Trivi. Trivi is an open source project, and for example, you can take Trivi um, to scan vulnerabilities in container images and also in infra as code configurations. And when you integrate the power of Trivi with AI, you can help your team to really prioritize and focus remediation efforts much more effectively. So think about ensuring compliance and enhancing security posture to your organization using Trivi and using the data that Trivi provides. The next thing will be CrowdStrike, Falcon. It provides kind of a cloud-delivered endpoint protection. So um, think about protecting your endpoints using AI. It can basically uh, detect anomalies and really analyze the behavior of the endpoint. It really offers a real-time threat detection and also automated responses. So it's really nice to take a look at this. And you have also Sneak Code, which is a developer-focused code security platform, and that leverages the AI with the knowledge of Sneak in security, and together they bring kind of a real-time testing suite into your code. So it's really amazing to see. The next thing and the last topic will be observability. And observability goes much more beyond than the traditional monitoring. It really provides insight into your health and performance of your system in real time. So in this topic, AI is really like changing everything in my eyes. And AI really elevates observability by analyzing data from logs, metrics, traces, and it really leverages the data that it has to detect anomalies, predict issues much better, even before they actually impact the users. And you can also automate root cause analysis using the right tools. And the AI combined with observability can really allow the DevOps team to address potential problems, ensure high availability, and also detect issues fast enough to avoid incident in production. So you have Moogsoft AI platform, which can show you how really AI can digest huge amount of data to identify issues really quickly and accurately. Um, and it significantly can reduce the time to resolution of really impactful incidents. And downstairs you have Datadog. So Datadog brings to the table many features. I love their product, and these features can really leverage your data, metrics, and logs, like we said before, and it integrated to anomaly detection, smart alerts, and even they have a nice chat that you can chat with to understand better incidents. So, for example, you have now an alert firing, and you can chat with the Datadog chat to collect more data about this incident. So it's really nice to see. Now, when we covered the topics that I wanted to talk about, but we also have like the high level best practices and common pitfalls when talking about AI integrated into the DevOps world. So let's start with the best practices side. And in the best practices side, I always say start small and iterate. Don't push your infrastructure to the limit really from day one. Keep building a consistent and iterated process to really integrating your infrastructure with AI. It's really important because sometimes I will talk about it later in the common pitfall side. But it's really important to keep it small and iterate slow and make it really a good and consistent process. The next thing will be always prefer explained AI. And by this, I mean that you need to make sure that you understand the decisions that your AI tool or agent is getting. It's really important because sometimes, and also I will talk about it in the black box problem, uh, the AI has a really impactful power, and we need to understand the decision that it gets, right? And also, keep in mind and keep your eyes open. Uh, like I said, with great power comes great responsibility. So, AI tools have a lot of impact on your infrastructure. It has a great power, but also a huge impact. So, use it carefully. And on the common pitfall side, um, I would say don't over rely on automation and AI. Obviously, that's what's going to happen, right? We're all going to be automating our infrastructure with AI, but do it slow, okay? Kind of create a human oversight on this automation. So really avoid lack of human oversight. That's really important, and also avoid high complexity and maintenance, because sometimes this automation can really complex our infrastructure and make it much more complex instead of making it much easier. So keep this in mind. Also, security and privacy, this is extremely important because for any organization in the world, I think you have intellectual property, right? You have your own data, you have your own components or even resources around the network or even in your drawer. So you need to understand that you want to keep your data in your house. You don't want to spread it over to the world. And there were many cases in the last few years that companies' intellectual property got leaked. So really, it's important to keep that in mind. And the last thing that I wanted to talk about is the black box problem. Sometimes you don't really know what your tool that you're using, the AI tool or the AI agent, you don't really know what it's doing, right? You don't know, maybe you know in which services it's connected to, but you don't really know what it's capable to do. So it's always important to set the right boundaries and permissions for these agents and for these tools, and always keep the best practices when it comes to configuration. It's really, really important. And we're going to finish this futuristic kind of talk with the future and AI, and then I'm going to talk about really about the day of a DevOps engineer in 2030. So my take in the future of AI and DevOps is mostly including a really big leap in security-oriented tools. So these security-oriented AI tools really are there to detect and run fixes live, not only um, suggest fixes, but also including fixing code vulnerabilities from end to end, right from the beginning to suggest you actions to take, and up to the top to actually fix your code without really a human interaction. About edge computing and IoT, it's all about data and processing, and I think that there the AI will take a huge spot in easing up processes and really maximizing the control that you have over the edge resources. Because think about it, you have such a many edge devices on the edge, and you really need to manage them. You need to maintain them, and the AI, I think, is the best candidate to really take care of this effort. Um, Integrating AI in sustainability and green computing, I also think will gain uh, huge velocity and huge attention as many regulation are getting much more stricter. About MLOps, I think it's really a hot topics already. Um, when it comes to AI, it's really MLOps is it's a thing. It's really a buzzword. But I think that as soon as we grow and as soon as the AI will take a better place in the DevOps world, I think that much more tools and frameworks of MLOps is going to take much more space in the world of DevOps. And last but not least, AI posture management. So I think that as AI will eventually be the main component in our infrastructure, I think that we will have to control it somehow, right? We will have many, many tools and agents all around the infrastructure, and we need to control it much better. So we will have kind of a posture management platform that will rule all of the agents and all of the tools. We will have like a human oversight of what's going on. And I think this is where the future of AI and DevOps world is going. And the last thing that I want to talk about is how I imagine the world, the day of a DevOps engineer in 2030. And this is going to be a bit futuristic. And I really wanted to finish this talk in a really futuristic thing that I wrote. I actually wrote this to understand how I can combine the ideas that I talked about before into the world, in the day-to-day of a DevOps engineer. So I'm going to read it for you. And again, it's going to get really, really futuristic, so get ready. So I'll just start with it. Your day begins with a virtual meeting in your augmented reality workspace where AI-powered bots present a summary of oversight operations and incidents. These bots already identified potential issues using predictive analytics, initiating automated workflows to address them before they even impact the users. As you review code for new feature, an AI assistant suggests optimization based on a deep analysis of your code-based performance and current best practices. It automatically generates and runs tests, adjusts parameters in real time. It's also exploring kind of potential issues. After this, for lunch, you join a virtual brainstorming session with your team, discussing the integration of a new quantum encrypted data storage solution. I'm going a bit far here, I'm sorry. Your AI assistant transcribes the conversation, highlighting the key action items and assigning the task based on your team's past performance and correct workload. This is actually something that Microsoft already have, and I think Zoom also in a way. I think in Microsoft Team with their Copilot, you can actually transcribe your meetings and also create tasks and assign people to them. It's kind of crazy if you ask me. After this, in the afternoon, you deploy a new service to a global network of edge devices, like we talked about. Edge devices will be a really impactful thing. And the deployment toolchain, powered by advanced AI algorithms, selects the optimal deployment strategy to balance load and minimize latency for users worldwide. Think about it. You can use AI to suggest or maybe choose the best strategy based on your usage in your application, your load, and you can understand how you can impact less on your users when you deploy new versions, maybe with A/B testing or canary deployments. Um, so uh, again, I'm going back to the afternoon. This deployment toolchain also ensures that the deployment will use the strictest security and sustainability standards, automatically selecting green data centers and optimizing resource usage to reduce energy consumptions. Here, I inserted the sustainability topic, the green data centers that I think will take a big place in our future, and also reduce energy and consumption, which is basically FinOps, right? We want to always minimize our cost, and with AI, it will be much more easier. And as your day ends as a DevOps engineer, you review a dashboard summarizing the day's operation, including automating contributors from AI system, because the whole day AI did stuff, right? You need to understand what the tools and the agents did. So you have kind of a dashboard summarizing everything. And that's kind of it. And to summarize this crazy futuristic story, I think that our workday in 2030, it's not that scary. It's basically kind of a mix of our creativity as a DevOps engineer. If you ask me, as a DevOps engineer, you need to be very creative with your solutions. And it's a mix of your creativity with the power of AI and the efficiency of AI. So I also gave a strong emphasis on sustainability, security, and monitoring. So uh, that's kind of it. The future of DevOps, as I see it, really offers a shift in how we think about building, deploying, and really maintaining our infrastructure and our software. And for me, it's really, really super exciting. So thank you all. And I don't know how it's going, but if you have questions, I would love to answer everything. But if you want, you can catch me on LinkedIn, maybe schedule a meeting at our site, permit.io. And that's kind of it.
Hello again, Ras. Thank you so much for the talk and giving us an outlook on the future. So, yeah, we got some questions submitted by the audience. I think you already tackled maybe some of them later in your talk, but nevertheless, I would say maybe you have something more to add. I will
Sure.
just read them to you. So, I mean, the first one is pretty straightforward. Great session. Is it possible for you to share your presentation with us?
Of
The
course.
slides. Yeah.
Of course. I just need your help because I don't know how to do it, but yeah, sure.
If you want to, you can share them with us via mail or something else, and we can include them in our recap. We are sending out the recap on Friday to all the attendees, and
Mhm.
I think that's the
Sure.
easiest way.
I would love
All
to.
right, then let's do it this way. Perfect. Thank you, Ras. And we go on to the next question. Is AI used for things like anomaly detection, like reducing false positives and stuff like that?
Yeah. So I will give my experience with this. I also talked about it The answer is basically yes, obviously. And we are using here at Permit.io, we are using Datadog. So we have alerts that basically are set to detect anomalies. So, for example, we have an alert that check how many 500 responses we have in our system. So, for example, 500, just to make it clear, it's really bad. It means that your service is not responding correctly. Something is broken from the infrastructure to your code. Something is broken there. So, we really want to understand what's happening. And obviously, if we have one, it's bad. But sometimes systems are not perfect. Sometimes you have these 500 and it's okay. But when it gets much more worse, you need to understand. So you can't really choose a number like if it's more than 10, then alert me. You want to understand compared to previous or forecasted data. You need to understand then when to alert. So Datadog gives a nice anomaly detection using their models and machine learning to really kind of create an smart alerts.
All right. Thank you so much for that answer, Russ. We got another question. Is the broad industry already accepting the adoption of AI-driven solutions in DevOps? If so, what factors do you think are pushing them in this direction?
That's a great question. First of all, I think yes. I think that in the last 10 years, I think the people that are getting the decisions in the companies, if you ask me, in the R&D organizations, eventually it's either the DevOps engineer, the developers. We make the decisions, right? We choose what we want to use. We choose whether we want a tool or we want to build something ourselves. Obviously, sometimes we have this manager that tells us, no, we don't have time to build it your own, so please use something. And I think as the movement and the power of DevOps engineer will understand that AI can really be beneficial for us, then we will adopt AI-driven solutions. But I think what will block us from doing so is the regulations. So things like compliance and let's say SOC 2 and maybe kind of ISO and HIPAA certificates will block us from continue to wherever we want. Because as I said, um, security and compliance around this, it's very sensitive. We need to understand how we not leak our company's intellectual property accidentally. So we need to do it smart. And I think it will happen eventually.
Mm-hmm. Yes, but I mean, yeah, these regulations are nevertheless very important, I think.
Yeah. Yeah.
So it's also AI isn't abused. But yeah, thanks for that answer, Russ. The next question, yeah, you already tackled it a bit during your last answer. In your opinion, what are the challenges or roadblocks that might hinder the bigger adoption of AI in DevOps? Maybe you have something else to add to this
So
question.
you're right. I answered about the security and compliance side. And if we deep down into the security, I think, and also it's something that Permit is going to take care about in the next future. So Permit is taking a lot of action in the identity access control world. And if you think about it, we will have tons of AI agents around our infrastructure, and they will eventually have access to things, right? Access to services. And we need to understand how we can give the right permissions to the right agents. So I think the roadblocks or challenges, or maybe the solutions, will be better agents identity management or stuff like this.
Mm-hmm. Thanks for that answer as well, Russ. Let's go on to the next question. Do you have some practical tips or best practices for organizations looking to integrate AI into the DevOps workflows?
So I kind of gave it in the slides in the talk. I can I can just suggest really to do it slow, do it really, really carefully. And if you have, I don't know, more questions, it's for all. Yeah, if you have more answers, just you can ask me on LinkedIn. We can talk about everything.
Yeah, let's start a mega thread
Yeah.
with everything. All right, thank you, Ras. Next one, are there any tools or platforms you'd recommend for implementing AI-driven solutions to DevOps?
So it really depends on which topic we are talking about, because again, the DevOps and the software lifecycle is really, it's enormous. You have many things to tackle, starting for planning, going to CICD, infra as code. So I think it really depends on where you're going to. But yeah, the tools that I mentioned are quite nice, but obviously every day there are many, many more tools that are just, getting published.
All right, thank you. Next one, interesting topic. In what ways does AI create a whole new field in DevOps? What opportunities does it unlock for organizations?
So I think, first of all, thank you. I think that MLOps, machine learning operations, it's already a thing. And it's not that it's only already a thing, it will get much more attention. So I think train and inferring and all of these concepts in machine learning, I think it will get much more traction and attention. So this new field will get much more bigger. The opportunities, I think, will basically it will give us, the development teams and the R&D teams, the opportunity to really take care of much higher things. So today we are taking care of CICD and stuff like this. This should be, in my mind, this should be basic. This should be a fundamental that we don't even need to take care about, because if you think about it, CICD is kind of, in many places, the fundamentals are the same. So we won't have to write it again and again. And I think we will have to take care about much more complex things, stuff like security. So I think security will get much more attention in the next few years.
Thank you. Yeah, we talked about it in an earlier question, but just to be more precise, how does AI-driven anomaly detection ensure scalability and automation in complex systems? The follow-up question.
Mm-hmm. How does AI-driven anomaly detection ensure scalability? So the obvious answer for this, like I answered before, is that anomaly detection can be used in the observability side. So you can observe your infrastructure much better, your code or your CI/CD. It doesn't really matter. But I think about when let's say autoscaling in Kubernetes will not only learn if it needs to scale out based on metrics. It will also understand if it needs to scale out based on anomalies. So think about, you get tons of new requests into your backend, and let's say it happens every Tuesday, or it happens every week, or every month, or let's say at the end of the year, right? We have tons of new Year's sales and stuff like this. So maybe in these phases, our anomaly detected kind of autoscaler will understand that it will need to autoscale our Kubernetes pods. So stuff like this, not only metric based, but also anomaly detection based autoscaling. I think this is a nice way to look at it.
Thank you. Next question. What are some KPIs used to measure the effectiveness of AI integration in DevOps practices?
Yeah, that's a great question. And I think I covered some of it in the pitfall. So as I said, don't rely too much on tools, automation, and AI, because sometimes it can unfortunately make much more complex maintenance. You can also need to think about your resources, about your engineers in your team, because maybe your engineers are not skilled enough, and it's okay because it's a new topic, the AI, right? So maybe they're not skilled enough to really maintain huge workloads using AI tools. So you need to understand whether it will be effective or maybe it will make everything much worse. How to really measure it? It's a good question. Maybe we can develop something.
Yeah, it's up to us to find an answer.
Yeah.
Yeah. All right. Thank you, Ras. Next question. We already talked a bit about it, but do you have any security concerns regarding AI in DevOps?
Yeah. So obviously, the quickest and like my answer for this is really the identity management, the access control management, all around AI. I will not dig into it too much because I already talked about it, but think about it. You have AI agents, you have AI tools, they have a lot of capabilities. You need to understand what they can do and what they can't do. So this is really, really important. And we are heading into it really soon.
All right, thanks. Next question. Yeah, I mean, basically your talk was about that, but what do you think will be some new trends in the intersection of AI and DevOps in the coming years? Maybe if you have some more examples.
Yeah. I think the intersection, if you talk about really intersection, the intersection is basically MLOps, because it's kind of getting the really the modern but old-fashioned DevOps. It's kind of tricky. Old-fashioned DevOps into the machine learning world. So think about that you will use AI to get your MLOps infrastructure much better. It's confusing, but I think the intersection there will be much really, really interesting. That's it.
All right, and we have one more question. How do you think AI-driven DevOps will evolve in response to emerging technologies such as edge computing, IoT, and quantum computing?
Yeah, so this is really an open question for everyone. It's super interesting. I think that in terms of IoT, we will have so many, let's say, like we have today, okay? So we have even air conditioners that are connected to the network, cars that are connected to the network, and we will have to somehow control them. And this will get done by someone, and this someone will be an kind of an AI agent that will basically control all of these devices. It's I think that's the next thing. IoT integrated into AI to really maintain the infrastructure of IoT. That's an extremely interesting topic.
All right, Russ. And maybe as a closer question to you, like personally, you gave us like a broader outlook on what will development be like in 2030. Maybe for yourself, what do you think will change for you in your field during the next few years, or maybe already has changed?
That's a good question. As I said before, in Permit, we are looking into this opportunity of actually building access control for AI. So I think that it will obviously affect me as a developer and a DevOps engineer in Permit.io. So we will start look at what we can do to actually prevent any misconfigurations or kind of leveraged access for these agents. And I think through this process, we will understand better also what are the risks or what are the challenges that we can that we should handle. So I think that's going to take my mind for the next few years, maybe. I don't know.
Yeah, so maybe on our next live day, you can already share some more insights on what has changed for yourself and your environment. All right, then, Russ, thank you so much for sharing all these insights, giving us this outlook on the AI future. It's a very cool topic, I must say. I was very intrigued in your talk. And so, yeah, as I already said, hopefully see you on another live day.
Yeah. Thank you, Ben. Have a good day.
Thanks, Ras.
And thank
Bye.
you, everyone. Bye-bye.
All right, and before we jump to the third speaker of the day, just a 2 minutes break. And right back to DevOps and the next speaker of today. She is site reliability engineer at Elastic. She's passionate about DevSecOps, serverless AI, and machine learning. And she's a strong supporter of women in tech. Welcome, Diana. Hello, Diana, you are muted.
Hi, everyone. Hi, Benedict. Hey. How are you?
I'm very good, Diana. Thank you so much for asking. I hope you are too.
Yes, I am. Excellent.
Perfect. Yeah. First of all, thank you so much for joining, Diana. And second, before we jump into your talk, would you mind sharing a bit about what we are going to learn from you today?
Yes, of course. So today I'm going to speak about serverless observability, in speciality about SLOs and transforms. So people will understand they will learn a bit more about SLOs, the SRE life incident management, and what are really transforms. So whether is it applicable to a smaller or large organization, we'll find out.
All right, then, Diana, I would say without further ado, stage is all yours.
Thank you. So I hope you can see my screen. Yep. So like I said, I'm going to talk about serverless observability, where SLOs emit transforms. So I've been with a bit about myself. I've been with Elastic for 2 years now as a site reliability engineer. I live in Valencia, Spain. I'm a mother of 2 young children, and I love traveling, reading, and doing sports. So a bit about the context of my talk. So why I decided to have this talk on SLOs, serverless observability, and transforms. Well, it was the fact that our main issue with the organization when it was migrating to serverless was scaling. So due to the very large data set environment, we needed our aggregations to be more efficient in dealing with cache results. So historically, we had two methods of manipulating the data. So the rollup aggregations, we summarizes and stores historical data for later analysis. Then we moved from this type of methods of manipulating the data, and we adopted the transforms, which is the current way we are doing things at the moment, basically that convert existing Elasticsearch indices into summarized indices. So why this change, basically, just to give a bit more context around this, is that due to the Elastic has migrated to the serverless environment, and basically we wanted to have some form of data, or some form of manipulating the data that, let's say, was a bit more, it was more efficient and was trying to scale up with the rest of the organization. So the summary for today's talk is going to be, I'm going to touch a bit on SLO concepts, SLO indicator types. I'm going to talk about the SLO architecture. Then I'm going to explain what are transforms, when to use them, and some of the use cases. Then I'm going to speak about burn rate alerting. I'm going to show you a demo, so everything done in practice. And basically, to summarize, to sum up everything, I'm going to speak about SLOs and incident management. So just to have a bit of a recap of the concepts around the talk, some of you are very familiar with these concepts on SRE, on service level indicators or objectives. So to summarize a bit, that the service level indicators basically are a measure of the service level provided. We usually define them as a ratio of good over total events. They range between 0 and 100%. So for example, we have availability, throughput, request latency, error rates, and the service level objectives will be then a target value for a service level measured by an SLI. So above the threshold, the service is compliant. For example, we have 95% of the successful requests which are served under 100 milliseconds. The error budget will be defined as 100% minus the SLO, and will be the quantity of errors that is tolerated. And the burn rate would be the rates at which we are burning the error budget over a defined period of time. So it'll be very useful at alerting before exhausting the error budget. So in terms of the SRE DevOps framework, we usually associate the concept of SLO with the SLA and SLI. So to have it a bit more, let's say, simpler explanation around it, the SLA will be the agreement that your company makes with your clients, whereas the SLI will represent the real numbers on your system performance. And then the SLOs are the goals your teams must hit to meet the SLAs. So to have, let's say, if you prefer like formulas, we usually have a couple of formulas in mind for the SLOs. So the SLOs will be typically expressed as a percentage of time that a service is expected to meet a certain level of performance. So for example, successful operations divided by total operations multiplied by 100. And the burn rate, we add the burn rate to improve reliability and quality of services, although it's not necessary, but it's used, let's say, for financial reasons. So in terms of what's a good SLO versus a bad SLO, a bad SLO will be vague, subjective, it will lack quantifiable metrics, it will have undefined threshold and no observation window. A good SLO, however, is very specific and measurable, user-centric, quantifiable and achievable, and time frame defined. Well-defined SLO will focus on a crucial aspect of service quality, will provide clarity, measurability, alignment with user expectations, which are obviously key elements for effective monitoring and evaluation of service reliability. So we'll go a bit over the SLO indicator types. And here I'm going to touch on some indicator types that we are using at Elasticsearch. So I'm going to present next the APM availability, APM latency, custom KQL, custom metric, histogram metric, and time slice metrics. So let's do a bit of dive into each one of it. So the APM availability, it's designed to work exclusively with APM failed transaction rates. So the users can filter on service name, environment, transaction type, and transaction name. It will support narrowing focus with a query filter, and will support also partitioning by any field present in the APM data. So for example, for such an SLO will be 99% of transactions are successful. The APM latency will be designed to work exclusively with APM transaction latency. So the users can filter on name, environment, transaction type, and transaction name, and will support narrowing focus with a query filter as well, and partition by any field present in the APM data. So for example, let's say an SLO will be 99% of transactions occur under 200 milliseconds. The custom KQL SLO will be designed to work exclusively with custom logs, and will have, so the document count for the good filter is used for the numerator, the document count for the total filter is used for the denominator, and will support partitioning by any keyword present in the index pattern. So for example, here you'll have an example of an SLO like 99% of log messages are not errors, and anything that you want to customize as logs. The custom metric will be designed to work with metric fields using a sum aggregation. So it will support basic math, Boolean logic between multiple fields, and will support partitioning by any keyword present in the index pattern. For example, let's say you'll have an SLO like 99% of accepted events have been processed. An histogram metric will be designed to work with histogram fields. What are those? Histogram fields will be very useful for storing pre-aggregated high-resolution data with minimal footprint. The users can define a range for the values. The counts are used for the good and total events, and will support partitioning by any keyword present in the index pattern. So for example, you'll have an SLO like 99% of events have a latency between 0 and 100 milliseconds. So the time slice metric will support multiple aggregations. So what we'll have here, for example, we'll have like average, min, maximum, sum, cardinality, last value, standard deviation, percentiles, and document counts. And due to the nature of these aggregations and their relationship with the bucket size, this indicator forces the user to use a time slice budgeting method. And it will allow the user to define a custom equation with multiple aggregations, along with a threshold for defining a good slice. So to have a bit of a view over the SLO architecture that we are using at the moment in the Elasticsearch, is defined in this scheme at the moment. So basically, SLOs are relying on the transform service to roll up the source data into roll-up indices. And to support the group by or the partition by feature, we have added a second layer which summarizes the roll-up data into an entity-centric for each SLO. This index also powers the search experience to allow users to search and sort by in any dimension. We will see everything put into action later on in the demo. This is just, let's say, like a definition of the architecture. So I've been talking a lot about transforms up to now, but what are really transforms? Probably you are familiar with the term, or probably you're not. The transforms basically are persistent tasks that enable you to convert existing Elasticsearch indices into summarized indices, which provide opportunities for new insights and analytics. For example, you can use transforms to pivot your data into entity-centric indices that summarize the behavior of users or sessions or other entities in your data. Or you can use transforms to find the latest document among all the documents that have a certain unique key. So when to use transforms, basically? You can have like 3 use cases, but obviously much more than this. When you need to complete a feature index rather than a top-end set of items. For example, this can be handy in use cases for machine learning use cases, when it's not possible really to use specific aggregations, or when you need to sort aggregation results by pipeline aggregation, with something that pipeline aggregation actually cannot do. Or when you want to create summary tables to optimize queries. And here we are talking about, let's say, where you're using some large data set and you want to have more efficient cache results. So we talked about how what are transforms, when to use transforms, and how to create transforms. So if you want to create transforms in Elasticsearch, you can go to the stack management in transforms in data, and you can click on the data view there. Obviously, you need to have already a data view created that you plan to use. For example, in the serverless framework, we can use any of the following that I populated there. So for example, serverless logs, metrics, traces, and so on. And then you can choose from the 2 types of transforms like I described earlier. So you have pivot transform or latest transform. So for this case, I'm using the aggregate, the pivot transform, which aggregates and groups your data. You can select the time range here that you want, add a specific filter for it, and next you can use some of the destination index. So this will be, let's say, an index that you created previously, like I showed you before. So it could be like, for example, serverless.logs index. And you could enable other filters here, like other features like continuous mode, retention policy, in case if you are interested to have other fields available as well, other features. And then before you actually start and create the transform, you can copy the payloads aside. Let's say this will be an example of such a payload. It will give you all the JSON definition that you have. You can use it later, for example, to embed it in a code if you want to use it as code as well. So once you have the transform defined and created, you can go ahead and create some alerts for it. So the same, you could go to stack management in alerts and insight in rules and create a specific alert for the transform. So the alert is called transform health. You can select it from the available stack rules, and you need to select your transform that you just created previously. And you can obviously enable some of the features there. For example, if you want to track whether the transform was not started, if you want to get alerts for unhealthy transform, and if you want to integrate it with any connector, like for example, if you're in DevOps or an SRE, if you want to alert via PagerDuty, Slack, create a Jira issue, or just simply send you an email. Obviously, we talked about some of the features via the Elasticsearch UI, via the Kibana UI, but obviously you can use the APIs to create such transforms and also SLOs. So you can use them, for example, to integrate it with infrastructure as code, like for example, Terraform. And these are, like, let's say, a list of some of the very popular APIs. You have later on, I added a resource page where you have all the APIs that you want to consult. And once you created, let's say, the transform and the transform alerts and the SLO, you want to maybe add a burn rate. But what is burn rate alerting? So burn rate alerting calculates the rate at which SLOs are failing over multiple windows of time. So it's less sensitive to short-term fluctuations by focusing on sustained deviations. And it will give you an indication of how severely the service is degrading, and it helps you prioritize multiple issues at the same time. So let's see a bit how this looks. So burn rates alerting work over multiple windows of time. So you have two windows for each severity, a short and a long one. And the short window is 1/12 of the long window. So when the burn rate for both windows exceeds the threshold, the alert is triggered. So why are we using this? Well, some, let's say, advantages of burn rate alerting is that it has reduced alert fatigue, will improve the user experience, will help you with a flexible alerting framework, and it has good precision. Whereas at the moment, let's say, there are lots of options to configure in this version of Elasticsearch. However, this will be improved with future versions. So burn rate alert is, let's say, a different type of alert, but basically you create it in the same way you created a transform health alert. So you can select the rule, start creating the rule. And in this case, it's called SLO burn rate. You select it from the menu of alerts that you have available, and will populate with this type of field of window with multiple features, multiple variables that you can select. An interesting one is the burn rate threshold. That basically tells you how long you have until your error budget is exhausted. And you can have different action groups and add them according to your priority, either critical, high, medium, or low. And you can integrate it as well, just like for the other alerts, with any connector, PagerDuty, Slack, Jira, and so on. Right. So let's see in action how this will work. So, for example, to create the transforms, like I said, you go to Stack Management. Here I already have some created transforms for you. And for example, to view one of the transforms, you just click under it. Will show basically a health pane of the transform. You can check it if it's degraded, if it's healthy, if it's unavailable, failed, and so on. And if you have any messages that's regarding the specific transform and the instances as well. Then you go ahead and create the new SLO by going to the observability panel there. You can choose the SLI type that you want that I described earlier. In this case, it will be, let's say, custom SLI. You input the query filter and the good query and the total query. And this will basically help you have the two queries that you're interested in. You can select the partition by feature. That could be either project ID or handling cluster, the rolling window, that will be 30 days, 90, or 7 days. And obviously the target value for your SLO, the percentile. You have 99% or 95 as you wish. And here you can input obviously the name, the description for your SLO, and add specific tags. This will be very handy for you if you want to check it later for your specific team or department. You go ahead and create the SLO. And then immediately after, we'll give you the option to create a burn rate alert. You have the same window I was explaining earlier, where you can modify the values as you want, or you can leave them by default, integrate them with a connector, and save the burn rate row. Okay, and once this is added, you can go in the filter and just look for your SLO that you just created. Will come up as a history type of list where you have all the list of your SLOs. And once clicking into the SLO, you have a very nice definition of historical SLI, some alerts that you have in your case, and obviously change it, modify it as you want. Next, here I'm showing you how to add some SLO panel to a dashboard. Once you create a new dashboard, for example, if you are interested to find out how your SLOs are operating, you can just add directly a panel like SLO overview, selecting, for example, the SLO you just created, the serverless one. And you can add some SLOs alerts as well if you have defined some burner rates to it. And right out of the gate, you have the dashboard that includes, let's say, for an entire region or for an entire cluster, you have some SLOs there that will give you the, let's say, the health status, also some information, the rolling window information, and obviously you include that in your dashboard along with some tags. Right, so we've seen this feature also that is available. And next, what I want to show you is how to interact with those APIs that I was mentioning earlier. So you go to the DevTools part in Elasticsearch Management in Kibana UI, and then you could use some of these API, for example, to find how many SLOs you have in a particular cluster. It will give you the IDs and the namespace information and any other parameters information that you created there. You'll be a lot faster to find out, for example, if you like it, than just clicking in the user interface. And you could go as well and interact with a specific transform if you want to have more information on a transform. You could get, like, for example, all transforms that you have created. It will give you the exact counts that you have for those transforms, and a lot of useful information for that specific transform. This is very handy as an SRE or DevOps engineer if you want to troubleshoot something. You are in the middle of an incident and you want to see, like, for example, hey, what's my transform doing? Is it healthy? Is it not healthy? How can I troubleshoot it further? You can either copy the ID of your transform as well and have a specific, very specific, narrowed, let's say, result on that specific transform. And obviously, you can interact with some statistics as well, like documents processed, indexed, deleted, and so on. So this is the part that I say we all like in terms of troubleshooting, because you can go ahead and just dive into a bit into more, let's say, of the nitty-gritty of how the transform is consolidated behind the scenes. And you could use other APIs as well. Like I told you, delete, create, and update your SLOs and your transforms as well. Right. So right now, after the demo, we will talk about. I will talk about a bit about the SLOs and incident management, because we touched on the subject, and see exactly what's the relation between the SLOs and the incident management. So I mentioned previously that, let's say, SLOs are very good in the SRE DevOps framework. But it's not only they are not only useful within that framework. So they extend to a lot larger, let's say, framework. For example, I explained that this talk is based on a real life case. This is part of a project I've been handling at the moment for the last couple of months. And what I noticed is that once you start working with SLOs, you don't really interact with just your team. You interact with a lot of teams. So you interact with the developers, so the software engineers basically that creates the SLO products. You interact with the customer support or the experience teams, because, like I said previously, you need to link your SLOs with the SLAs, so the service level agreement. And then you need to find out, okay, so what are those SLAs that our product is responsible for? You need to speak and communicate with the product managers, let's say for defining the burn rate alerting as well, or for defining the values for your SLOs, whether, let's say, 99% SLOs or percentile 99 or 95, maybe it's better for your environment, or even less. So you need to be in constant communication with the product managers to find out how the product is created and what you need for your use case. And of course, with data scientists. So a lot of the talks were coming back and forth with ML engineers as well, that they use the feature a lot. So yeah, you have the whole panoply here of teams that get together, how to use the SLOs, and these are constantly changing and interacting. So some of the what I mentioned before, so some of the interesting takeaways I consider myself, in my opinion, for the SRE engineer or the DevOps engineer in relation with incident management is that you need to understand the user expectations. So for that, you need to speak and be in communication with the customer support, with the product managers, with other stakeholders in your company, to find out, okay, what is the customer expecting, what is expecting of us, of our agreements, and so on. You need to define the key service level indicators that work best for your organization. So how well is your system performing, basically? And then you need to quantify the service level indicators. Here you need to understand, okay, do we need to adopt a specific metric? How are we gonna monitor, basically, how are we gonna define those service level indicators? Then we're gonna need to consider the user impacts it will have on us. So here we are speaking about, let's say, the SRE engineers that will be, let's say, in the middle of an incident, and we'll need to consider a bit how will this affect the SRE engineers. You need to balance the reliability and innovation. So SLOs are very good here when touching with burner rates rules, because here, like I mentioned earlier, the burn rate alerting is helping you figure out well before your SLO is unhealthy. So, or when the SLO, let's say, is breaking. It will leave you a bit more, like, let's say, will give you a bit of peace of mind, alerting you before actually having an incident. You'll use the historical data for informed decisions. So when creating an SLO, you need to remember, okay, do I need to look at older incidents? Do I need to take into consideration historical data? If so, do I need to adjust the values of my SLO? Yes. Then you have to iterate and refine. So like I said before, you need to be in constant communication with all the stakeholders. For example, if you agreed to define an SLO and an SLI, maybe in, I don't know, 3-4 months from now, or maybe if you're taking a new customer aboard, things will change, the values will change. So you constantly need and adjust that definition. You'll need to monitor and alert accordingly your system, and you need to document and communicate. Here I'm talking about, let's say, for example, runbooks, about having some dashboards available as well that will help you, give you some information, and being in constant communication with the other teams as well. And not the least, collaborate with other teams. So this is a team effort, an organizational effort of defining the SLOs. Is not just the responsibility of the SRE DevOps teams, but it's the responsibility, I think, for all stakeholders. So if you want to have, let's say, a reliable, efficient organization, yeah, you need to constantly spend time in collaborating, communicating, and understanding your system performance. So in essence, a happy transform means a happy SLO. You cannot have one without the other. So remember, if your SLO is not looking so happy or is unhealthy, you need to check your transform. So you can consult a list of resources I put for you that basically will tell you how to create an SLO, how to create a transform, how to interact with those APIs for transforms, how to scale the transforms, of course, because these are very dependent on the organization type that you have. You can check how to create the burn rate alerting and obviously other information as well. Thank you so much for your time. You can hit me on LinkedIn if you have any more questions. And also on my GitHub personal account, you have the slides already there. Thank you very much for your attention.
Hello again, Diana. Thank you so much for the talk. Yeah, maybe you could send us all the links from you, like to your GitHub, then we can include it into our recap newsletter on Friday. So
Perfect.
every attendee has access to it. Perfect. All right. Yeah, we got some questions and some time left. So I would say let's tackle them right away. So, I mean, as always, sometimes the question came earlier in your talk, and
Yeah.
sometimes there are like, yeah, it's overlapping maybe with things you already said, but nevertheless, we like to address them again because maybe you have to add one or two things. So yeah, first question, how do you handle SLO variants in a serverless setup?
Right. Yes, very good question. Obviously, the SLOs can change, like I said previously. So this is something that you need to constantly analyze and, let's say, monitor. It's not, I cannot have a solution that will fit all. So I think everything depends on your organization, how you have everything set up. Let's say let's say the clusters, for example, if you're running, I don't know, 100 Kubernetes clusters, or if you have a large, small, medium organization. It depends as well on your, let's say, other stakeholders as well, like I said, product management, like customer support, and so on. In my opinion, is that the SLO variance that will be something that you need to keep an eye on and test it. And I think that it's not something that you can go up ahead and make it from the beginning. So you don't really need to aim for a perfect product or a perfect result. You just need to have some basic SLOs from the beginning. What I always suggest is to have, let's say, for example, like latency SLO or some custom SLOs that will measure, for example, the CPU that you have on the clusters as well. So very basic few SLOs that will not be something that you cannot modify later on. And then according to the data or the feedback that you receive from your serverless setup, you can work upon those SLOs. I don't think there's a very good solution for this in terms of, okay, you need to do this and that in according to the variance. It's just basically monitoring and adjusting those SLOs with the feedback that you receive from your, let's say, infrastructure.
Mm-hmm. Thank you for that answer, Diana. Let's tackle the next question. Can you share tips for setting realistic SLO targets?
Yeah. Okay. I think that's a very good SLO target would be not to aim too high and not to aim too low. In terms of everybody will, let's say, right out of the gate, or like a theoretical SLO will be like to hit the 99 percentile SLO. I think we'll need to be more realistic and add like a variable there that is less, let's say, ambitious. So you can start something with 95% or 90%, and then work your way according to the feedback you receive from your organization, or from your tools, basically. I think that's a common advice in the SRE world will be to not make it too high or too low, somewhere in between. And obviously you need to check with your SREs, with your engineers. Do you think that, for instance, that SLO is too ambitious? You can check with the incidents that you're receiving, for instance, from on-call, and adjust it accordingly.
Right, thanks for this answer as well. Let's jump to the next one. What tools do you recommend for SLO monitoring?
Right, good. So my talk was basically tailored for Elasticsearch, for monitoring the SLOs within the Elasticsearch. Obviously, there are lots of tools there for SLO monitoring. It depends on the products that you are using. So it could be either open source or something that you have developed in-house. I think that I would prefer, like in my opinion, an SLO monitoring tool developed in-house, because then you have something that customizes perfectly with the system that you have as well, that you developed. I wouldn't recommend right out of the gate, okay, use an open source one. Obviously, you can go ahead and use that one. It's very good, but I think better to integrate it with a product that you made in-house. Why is that? Because then you can speak and keep in touch with the developers from the team. You can give constant feedback as an SRE and DevOps to what features you want to have in that monitoring tool. And I always think that's a very good experience, and it's the better way to achieve that.
Right, thank you so much. Next question, how do you measure the impact of SLO improvements?
Right. Yeah. I think a very good way to measure the impact of SLO improvements is to keep track with other teams and maybe with management. Like I said, SRE or the DevOps engineers are really fragile here. So we don't really we are not really to be held accountable for changes, let's say, at upper levels. And for instance, even in the customer support area or experience teams, how they are called. So you need to be in contact with those teams that do measure, for example, the SLAs. So they keep in they keep in contact with the customer. They keep in contact with SLAs, with service level agreements. And at that specific point, you will say, okay, we performed well, we are doing good, so that means our SLOs are also performing very well. In the case that you have a feedback that is, I think, contradictory, so you have a contradictory feedback from the customer or from the customer support with the information that you see in your system, then maybe you need to how can I say, to have a meeting or organize a meeting to discuss those results. If your internal system performs well and you have the monitoring tools and you have the, let's say, the proof that is performing well, then maybe you need to adjust, or you need to ask to adjust the SLAs. It will be, like in perfect consonance sync with the SLO improvements that you have.
Right. Thank you, Diana. We got another question. How do you factor in cold starts when calculating SLOs?
Okay, right. So I think probably here, do you mean more or less, or I'm thinking that you mean cold starts when there's a brand new, let's say, system and you never had SLOs before, and you're just trying to use SLOs right out of the gates. Well, I think it's the only thing to do it is just do it. Like you start with like a few SLOs, like I said, is not don't take it the path of being too ambitious. Start with very basic SLOs that you can measure well. I give a couple of examples, like latency SLO, measuring the CPU, like a system CPU, or something that is very, very specific for your system. Start with 2, 3, 4 SLOs. add, let's say, a percentile that is not so ambitious as well, and see how you're performing as well. Gather more data, and in, let's say, 2-3 months, you'll have enough information to redirect or basically adjust your SLOs and percentiles.
Thank you, Diana. Next question. How do you ensure SLO alignment across multiple teams?
Sure, 1 second.
Yeah. Stay hydrated.
Of course. Well, actually, this is a very good question in terms of team collaboration and team communication. So I had very good feedback in discussing not only with the SRE team that I'm part of, but with other teams that obviously they also use SLOs. So the good thing is that even if other teams will have more or less the same SLOs, you will analyze and you could share the feedback between the teams. So, for example, your team will measure the SLO, but maybe they will measure on from a different perspective, and there'll be other teams measuring on a different perspectives. And then you can reach in the middle and discuss those results. And obviously, if you're part of a large organization that has a lot of teams, you also need to have specific meetings to discuss the results of those SLOs. I think there is nothing like a solution here than to figure out whether those SLOs contradict each other, or whether you need to work more on the, let's say, monitoring, alerting side, or basically you need to redefine a bit the whole system design behind the SLO. So it's right out of the gates. I would say just aim for cross-team collaboration and communication.
Yeah, good tip. Not only when it comes to SLOs, but also when it comes to SLOs. Thank you, Diana. We have another question. How do you prioritize SLO improvements in a backlog?
Right. Yeah, that's quite interesting. Yeah, I know. I usually think that the SLOs will get prioritized immediately once there is a big incident coming up. So once you have, let's say, a severity 1 issue, severity 2 even issue, will not be the only one that will prioritize that specific, how can I say, issue that will say, okay, you need to improve your SLO. I mean, it's obviously not good to have to prioritize an SLO issue after you have an incident, but it will be a bit kick in the back, in that sense, and it will help you like prioritize the SLO. I think to be proactive, you need to always have a mind, or you need to have constant sessions of prioritizing those SLOs. It will be like, let's say, for instance, if you are in a sprint, you need to have maybe like a recurring issue to prioritize. Okay, you have a November sprint. Okay, how we are checking those SLOs. How we are with those SLOs. Do we need to improve them? Also, think about releasing new features in your organization, or in your. Sorry, I need to
have a sip of water. Nope.
Right. So, for example, when there is a new release scheduled, I would assume that you want to prioritize those issues with improving the SLOs, meaning that you need to see beforehand where are you doing, if the SLOs are up to date before hitting that upgrade. Normally, we all know that when you're upgrading your system, more or less you are prone to some incidents that will trigger in production, for example. And my good guess is to do, let's say, like in-house keeping of your backlog and prioritize those SLOs right out of the gate.
Right. Thank you for this answer as well, Diana. We got some more questions. Let's tackle the next one. How does user feedback influence your approach to setting and refining SLOs? Should I prioritize defining the product or establishing SLOs first?
Right. Yeah, it's very good questions here as well. So I think it's the user feedback is very, very valuable. It can be either, let's say, internal feedback, like from other teams, or external feedback. Obviously, the SLO normally is being checked like more like an internal feedback, but I think it's very good to keep an alignment between the two. Let's say always keep. I mean, I will give myself as an example. During the last few months I was working on this project, we always kept in touch with the product team, and we always kept pushing for product features and so on. We try to keep align everything in terms of priorities, because there are always priorities and backlog of priorities. Whether a feature is let's say it's very familiar. Sorry, it's very familiar. It's very popular. It's essential or not. And if the user feedback points to a feature that can be done quickly, or it's more complex, will take several sprints, or not.
Yeah.
So here you need to establish with the developer teams, okay, is this feature something that we, let's say, as a majority want to have? If so, is it needed? It will be really useful. Yes, then we'll put a priority on it and start working on it. And I think, yes, I do agree that the products should be developed in sync with the SLO. I don't think one should come in front of the other. I think right out of the gate, you should have those SLOs defined. But obviously, if you have very good feedback, or if you want to address the feedback to the product team, do so, because that's the only way to improve your SLOs going further. So, yeah.
Makes total sense to me, Diana. Thank you for this answer as well. And we have another question. How do you handle SLOs for third-party dependencies?
Okay. Yeah, cool. Let's say that's an interesting question. Okay, I'm not really sure about that in terms of in my experience to have such a big experience on this as well. But I would say, like, obviously, if there are SLOs that you have been using for a little while, then it might take a while to get accustomed to those SLOs. Obviously, you need to keep in contact with the, let's say, manufacturers of those SLOs. I mean, if your organization decided to adopt a third-party dependency, then it has to have some kind of, let's say, forum or some kind of way of keeping in contact with the product, or maybe other organization that you partner with is already using it. You got very good feedback, and then you are using it as well. So give it time. Try to see exactly how your organization is handling it, how you let's say how you manage it. Do you receive good feedback, not so good feedback, in the sense that you want to continue using that third-party dependency, or drop it and use another type of SLO? I think here it depends on your personal feedback, so on your organization feedback. In time, you will know whether that specific third-party SLO suits you or your framework really well. And then in terms of developing that specific product, then you need to refer to the manufacturer of that SLO.
So, as so many things, it comes with experience.
Yeah.
Thank you, Diana. We have another question. How do you manage maintaining service levels while also introducing new features?
Oh, yeah, very good question. I would say in introducing new features, I mean, doing the two tasks should be like, obviously parts of two different teams. So I won't see here like SRE is working on introducing new features. I see more like an issue for software developers, or like software engineers or developers that let's say they are focused on upgrading or updating the SLO products. I think you as an SRE or us as SREs, well focused on maintaining the service level. So that's one part. So the reliability of the system is one part. And the SRE team or the DevOps team is going to be focused on that specific objective, while the new features, let's say, or updating the product itself will be the focus of the developers team. And like I said, you need to be in constant communication, and you need to keep in sync. Whether you hit a wall, let's say as an SRE, or you need a feature that is so essential for your work that you want to see it coming up, obviously you need to, let's say, you need to prioritize it, or you need to ask the developer side to introduce that new feature. I don't think the developers will start working on a feature unless it's really necessary. So unless that will mean, let's say, more work for them when it's not really needed. So here you need to be in constant sync, one team with the other. And yeah, you could do both at the same time, or you can just wait a bit until the next feature is going to be released.
Whatever fits your team best. Thank you, Diana. And another question. What's your approach on documentation and tracking?
Yep. Very good. So I think everything here, it's, as I described a bit in my presentation as well, comes with integrating the SLOs or SLIs with alerting and monitoring. So my approach here will be like already have some alerts defined. So already have like a panoply of alerts defined, and introduce the SLOs let's say in coordinates with the runbooks that you have at the moment. So it won't be like something that you've never seen, let's say like an SLO that's really something really amazingly new. I think more or less you will have a track of it in your documentation or your runbooks. If it's something that comes right out of the blue, then you need to adjust accordingly. But 99% of the time, you'll have already documentation in place, or you need to have some small adjustments to it, and add a bit, let's say a bit on a monitoring layer on top of those SLOs. Like I explained, you can add a burning rate alert next to it, or a transform health. That's just one example. And just, how can I say, complete a bit the, the vision of that SLO. And if you need to change it, do so, just like for any other runbook, just for like any other incident.
Right. Thank you, Diana. And another question. What are the scalability and reliability impacts of integrating transforms in your serverless setup?
Sure. Yeah. Great question, because actually it touches with the context I was mentioning at the beginning of my talk. So we noticed that, for example, with the serverless setup and migrating to serverless, that transforms were performing better in terms of, adjusting. Sorry, so in terms of being more efficient with such a large setup and so on. The normal aggregations that we had in place were not doing so great in terms of flexibility. So the whole new engineering, let's say the whole new engineering method around it had to be changed. We had lots of bumps in the road in the sense that we noticed the product itself, the transform product itself, was developed over lots of, let's say, upgrades and so on. This is very personal, or let's say it's very it's very personal to the setup or the infrastructure you have in your organization. I would say do it and learn as it is. So for instance, one upgrade of a system will lead you to a new issue in your transform, and you need to adjust that product, and you need to come up with new features. Like I said, one solution doesn't fit all. And yes, I think that transforms, at least in the case that I presented at the moment, suit us very, very well in terms of scalability and reliability. And we are seeing a lot of, let's say, positive feedback in that terms, as well as, from my side as an SRE DevOps engineer, it's working really, really well.
All right. Thank you, Diana. We have time for one more question. 2 minutes. What is the point where you should think about adding SLOs? Does it make sense to implement SLOs also for small products like a web application, for example?
Yeah, of course. Obviously, what I think here is that what is the point when you need to think about adding SLOs? Well, is the point when having them will hurt your infrastructure or not? Do you think you're going to have an added value or not? Basically, will add more complexity and more headaches to your infrastructure or not? If it's obviously, you can add it as well for small products, but in the end will be like, does it speed up or does it add more efficiency to my product? Does it give me good feedback? Am I seeing any positive impacts on it whatsoever? If not, drop them. It's obviously good to have some SLOs, but only when you see some added value to it. If you don't see any added value to it, then probably just having monitoring and alerts and so on will suffice.
Don't force it, basically.
Yeah, exactly.
All right. Diana, thank you so much for the talk. It was a very interesting topic, if I might say. Very informative. And yeah, with that, I hope to see you on another live day.
Perfect. Thank you so much for having me. And I hope to see you soon again. Have a great day.
Thank you, Diana. You too. Bye.
Bye.
All right, and we jump right to the next speaker of the day. He is DevOps coach at Team Rockstars IT, specializes in guiding teams to excellence through coaching and focusing on continuous learning. And with his over 20 years of expertise in the field, he certainly knows what he's talking about. Very welcome, Jacob.
Well, thank you very much for that introduction, and thank you for having me.
Yeah, thanks for joining us, Jacob. So before we tackle your topic, would you mind sharing 1 or 2 words about what is your topic and what we are going to learn from you today?
Yes, definitely. Well, if you think about DevOps and you do some research on the terminology of DevOps, you see a lot of definitions. And I think if you look at the program of today, quite technical subjects, I guess. But I'm going to focus more on something like process and culture. And in my opinion, and in a lot of other opinions, DevOps is like you can split it up in technology, process, and culture. And when you think about software engineering, software systems, many times people are talking about socio-technical systems. And I'm going to focus on the socio part of socio-technical systems. So it will touch on technology, but a lot of it is more or less social engineering, I guess. So a lot of methods and methodologies to create a better flow. Maybe that's it.
That sounds lovely, Jacob. Then I would say without further ado, the stage is all yours.
Thank you very much. Yes, well, I'm already introduced. Just a quick introduction. Jacob Duizer, live in the Netherlands. I'm an IT consultant. I work as an Agile and DevOps coach, team topologies advocate, and I'm working in an enabling team, which I might explain a bit later. And without further ado, let's jump into the subject. And let me just think about how do you go to work? You know, every day we go to work. Some people jump out of bed. They are eager to get to work, and others are not. Some of us might even feel miserable. And well, there's a big chance that if you feel miserable, that your organization's performance might also be very miserable. And when you think about the differences, why are people happy? Why are people not happy? Why is the one organization really having a good flow of value and the other organization does not? Is there anything we can learn from the organizations that are having a better flow, and what can we do to improve it? And first of all, what is flow? If you think about flow, you can think about a constant stream of updates to your services, to your software, value for your clients. And if you have a good flow, you will probably have happy clients and a happy you. At the other hand, fast fluff, I called it, unused projects. You are releasing bugs, wrong features, unhappy customers, a lot of complaints, also unhappy you probably. So, DevOps coach, as already mentioned, I work as a DevOps and an Agile coach, but what does that mean? You hear a lot of people who are an Agile coach or a DevOps coach, and what are they bringing to your workflow? So in this session, I want to explain what I do as a DevOps coach, what tools I use, why I use them. I believe there's a lot of information, but at the end, I will share the resources I used so you can look into it. If you have any question, also feel free to contact me later. And so that having said, let's talk about the rest of the talk. I've been doing this kind of work officially and unofficially for a number of years, and just recently I read a book which is quite new, Wiring the Winning Organization, from Gene King and Dr. Steven Spear. And when I read the book, I just realized that many things they are explaining are things I have been doing for years already. So what I'm going to use is I'm going to use their model to structure my talk. But first of all, let me quickly jump into something called the Agile coaching wheel, because many people think when you say I'm an Agile coach, that you are a coach on the subject of Agile. Well, in my opinion, I am not a coach that is coaching merely on Agile, although I do. But I see myself as being Agile as a coach. And I use this Agile coaching wheel to find out which type of coaching I need to use for certain problems. So maybe I need to do facilitating or coaching or serving or leading. So I am Agile in the way I coach. And then about the model of wiring the winning organization, which I will use during the talk. It's an eclectic model, and as the title of my talk also use the word eclectic, and if you're not familiar with the word eclectic, it means you are not sticking to one methodology or one idea, but you use as many models or methodologies as you can think of, as long as they help solving your problems. In this case, this model talks about three very important words: amplification, slowification, and simplification. And the authors of the book say that slowification is not a real English word, it's a made-up word because they didn't find a good English word to use. What it means, just in short, because I will deep dive into the different topics later, amplification is about making audible what the problems are, listening to the problems. Slowification is slowing down, looking into the problems and looking how to solve them. And simplification is a way of making your problems simpler by breaking them up or doing other things. It's a very interesting model. If you read the book, you can see that they use it for different problems also. It's not only for software organization, but it's kind of high level, so you can use it also for different organizations. When we talk about organizations, as I said already, organizations, especially in software development, are socio-technical systems. People are working with other people on different levels, on different systems. And you can break them up in three layers. The first layer, the technical objects being worked on. Think about code or maybe car parts or maybe a patient in medical care. The people working there are the experts, are the domain experts. Then you have layer 2, the tools and instrumentation. They are the resource, they make the resource available for layer 1 to do their job. So you can think about platform teams, other kind of teams that make sure that level 1, layer 1 people can do their job. And then layer 3, the social circuitry, is about processes, procedures, routines, the real social part of an organization. Leadership is part of layer 3 also. And why am I explaining this? That's because the tools and methodologies I use will jump through all the layers. Many times you see that leadership should be involved, so you are working in the layer 3 environment, but you are working with teams that are doing the actual work, so you're also talking with layer 1 or maybe with layer 2. So it's good to think about what the differences are. So let's start with amplification. I think maybe we all know what this picture is saying. See no evil, hear no evil, talk no evil. Sometimes it feels like that in our organization. We ignore signals, or we do not speak up our mind because we think, well, who cares? Or I have been doing that for a long time already. Nobody is listening. So how can we make changes in that behavior? How can we make sure that issues are being raised, are being addressed, that people are listening to what the problems are? And what is stopping us from doing that? Well, there's a lot of books written about this, but it's a lot of these issues are, they have to do with psychological safety. And there's also something like the Western organizations model, which I share in the next sheet. But if you talk about psychological safety, many people, they just don't feel secure to say what's happening because maybe you're afraid to lose your job, or you are afraid that if your boss asks you for more information, you don't have the answers, or maybe you are afraid to admit that you made a mistake. Western organization typology is made by a sociologist, Ron Westrom, and it's saying that there are 3 types of organizations: pathological, bureaucratic, and generative. And just in short, the pathological, the one on the left-hand side, they are characterized by a large amount of fear and threat. People keep information for themselves for political reasons or for other reasons. Then bureaucratic, that's more or less about doing things by the book, not going outside of the box, and a very bureaucratic organization. And then generative, which is really about continuous improving. Focus on the mission. If something is wrong, try to fix it. Listen to people. What are they saying? If you think about amplification and listening about what is happening in your organization, you can think about it as a feedback loop. And I have an image here of a feedback loop with a few steps. And then you can see what kind of steps you need to have proper amplification in your organization. Well, first of all, somebody needs to speak up. There's a problem. It has to be submitted. It has to be received. And something has to be done. And if you see this feedback loop, there are so many steps where things can go wrong. Signals can get lost. Signals can get misinterpreted. Problems might not be solved. Maybe your organization just doesn't care about what people are saying. So what are the tools that we can use to improve on amplification? How can we listen better? How can we act? So let's look into one of the interesting tools you can use. And one of them is called the Gemba walk. The Gemba walk comes from Toyota Production System, and Gemba means the real place, or the place where the actual work is done. And what happens is that you go with your leadership, you go around asking people questions like, what are you working on? Is there a process? Is there a problem? Can we fix the problem? Do you see room for improvement? And the important thing of having Gemba walks is really show interest, not trying to blame people, not trying to improve things quickly, but really gather information about what's happening in my organization. One of the stories I was recently listening to was that people from America went to a Toyota plant and they asked the CEO, but how many time of your day do you spend on having Gemba walks? And he said, well, like every hour for about 15 minutes. Because what he's doing, he's looking at people that are doing the real job, showing interest, and just looking at where can we improve. And that's interesting. Like, leadership should be interested in what's happening, not by demanding people to do what they think they should do, but really look into what's happening. I don't know if you have ever read The Goal, but in The Goal you can see The Goal is a book written by Goldratt. They are also doing that. They're really going and looking for constraints in the organization. What is the part in our organization that's really stopping us from having a good flow? Ask people what's happening. Can we improve the process? Can we eliminate the process? Can we just change the problems there? So the Gemba walk is a very important tool to do that. And also, if you really show interest and you are open to listen as management, you will see that probably your psychological safety will improve if you allow people to admit they make mistakes. Just listen to them and don't correct them or blame them. Another tool which is very interesting is the Anden code, which also comes from Toyota production system. And if you look at the actual implementation of the Anden code in the Toyota production facilities, they had literally a red cord going through the whole assembly line of cars. And if anything was wrong or anybody saw a way to improve the process, they could pull the line and everything stopped. And then first some manager will walk to the guy or girl who pulled the cord and thank them for helping them to improve. So not asking what's the problem or why do you stop? No, thank you for finding a way to improve. And then they are going to look at, okay, what's the problem? Can we improve it? And after a while, maybe they improve the system, the whole organization starts working again. This is also a way of improving psychological safety. Just pulling the cord and say, well, I did something wrong, or maybe I made a mistake, or something is wrong. Please fix this for me. I had a story which kind of related to this. I was coaching a junior developer, and he was telling me that he caused an outage on production. His first outage on production. I think he was just working there for 2 months, and he was kind of sad. And I was just telling him that, well, congratulations for doing that. That's reason to celebrate. And he was looking confused. Why are you saying that? Well, you are showing us a way to improve, because you could cause an outage on production, which shouldn't be possible. So let us fix the problem and be better. And then another interesting story is, if you ask somebody what happens if the same guy makes the same mistake a week later. Should we fire him or shouldn't we fire him? And then many people will start saying that, well, maybe we'll give him another chance and let's see what he will do. And next week, same problem again. What do we do? Do we fire him? And then many people say, well, maybe it's time to have a really serious talk about his job. And then I'm saying, but what did you guys do to make sure he can't make the same mistake again? So it's really about improving your organization and not about blaming people. Another interesting technique is something called Spotify Squad Health Check, which you can do maybe during a retrospective with your team, or maybe just doing once in a while. I have a deck of cards. I even have many of them. I have different versions. And on these cards are questions like, do you feel a pawn or a player in your organization? How rapidly do you work as a team? How easy is it to release your software? And then you can use something like a traffic light. You show if it's green, or maybe it is red, or it is orange, just to show how your team feels about it. And by recording the answers, you can look at trends. Maybe we are improving on our culture, or maybe we are improving, or maybe we are not improving on our easy releasing software. There's something I didn't mention yet, the DORA State of DevOps report. I don't know if you are familiar with it, but what they do is every year they send out a questionnaire to more than 30,000 developers asking questions about their organization. Questions like there are in this squad health check, but also other questions about what are you doing for DevOps? Are you doing continuous integration, continuous testing? A lot of questions. And out of these questions, every year they come up with a state of DevOps. And out of this state of DevOps, they create key capabilities which they believe can really improve your organization. And many of the questions out of this squad health check are about key capabilities. And in this case, you can think about a key capability like well-being or job satisfaction. The reflection on individuals' happiness and joy can really is really a big indicator on a healthy work environment. Another tool which is very important to do is retrospectives. It's also about psychological safety, asking the team, how can we improve? What did we do the last sprint or the last day or whatever your flow is? can we improve on what we did? What are we going to change? As I said, the DORA metrics. The DORA report is also mentioning things like learning culture. So if you think about retrospectives, it has to do with learning culture, well-being, job satisfaction, about can we as an organization listen to what you are doing. So these are just a few tools. There are many more to improve the way how your culture is and how you listen to what is happening to your organization, how you can improve. Then the next one, slowification. If you know there is a problem, you haven't solved it. So how can you solve problems in your organization? And slowification, or create better conditions to solve complex, difficult problems, is about system 1 and system 2 thinking. Many times we do things without thinking too much, which is fast thinking, system 1 thinking. And many times you need to slow down and really take time to think about what is the actual problem. That is slow thinking or system 2 thinking, which is way more difficult because many times you just want to act like on muscle memory. You just want to act because you have been doing things the way you do. So let's just do them again because they used to work. So fast thinking, you use heuristics, quick, reliable answers. They might be inaccurate because you might be biased. As I said, you have been doing it this way, so they will work again. You're not sure. Slow working is flexible. You can improve understanding, but it requires time and patience. And you need to be open to really slow down and fix your issues. When you think about slowification, you have to think about the 3 P's: planning, practice, performance. So you slow down, you make a real plan. What are we going to do to fix this problem? What are our goals? How are we going to make experiments to find if our plan will work? And actually, when you talk about performance, build in tests and look for feedback. Did it work? Planning, practice, performance, which might actually sound familiar because it's like agile working, DevOps, plan, do, check, action, feedback loops. Slowification, as I said, there are 3 major ways of slowification: incrementalization, modularization, and linearization. And the first one is really partition what is novel. You have a problem which is on top of something you already know. So split up what you don't know, the unknowns, the complex work from the things you already know, the complicated or simple work, which I explain later. Modularization, break complex systems up in smaller, simpler pieces, less coupling. So make sure you don't look at the big picture, but make it smaller actually, so you can comprehend what's happening, what the problem is, make small steps in improving. And then linearization, that's partitioning of operations, so you can work in parallel on the same issues or in different issues. Also decoupling. Cynefin, I think I love to show this picture, not only because it's an awesome picture, but it's also a very interesting framework, the Cynefin framework, which says there are different ways of different areas in which we do work. And I have already said something like unknown unknowns or known unknowns, but if you look at this picture, you can see there's something like simple. Simple means, well, we know what the problem is, we know how to solve it. It's about the known knowns, nothing difficult there. Then you have complicated. We have many known unknowns. So we know what we don't know. For example, you are going to do things in a lean way, lean manufacturing. You are producing cars. You know so many things, maybe not everything, but most of it is known. And complex, which is a lot of times the area where we are in when we are doing software engineering. There are many unknown unknowns. We just don't know what we don't know. So we have to look into a way of making small steps, making problems as simple as possible so we can try out things and get better in small steps. And then there's something like chaos. When there's real chaos, there's not really a point in searching for questions or answers. You should just act to try and stabilize and see what happens and then respond. And hopefully you get into one of the other areas. For example, when you're drowning in a fast stream, you are not going to think about, well, how do I learn swimming? No, you better just do something or you might drown. So the Cynefin framework is about gather information about your problem, identify the domain, and move on. So what can you do to actually measure things? How do you know that the problems you are identifying are being solved? Well, some of the metrics, flow metrics or DORA metrics or DevOps metrics, maybe they are familiar. They are deployment frequency, lead time for change, change failure rate, failed development recovery time. Just to explain them, I like these metrics. I like these metrics more than using things like story points because they are hard measures. I can really measure how many times a day does your team deploy. And when you deploy, how many times do you introduce new bugs? And if you do introduce new bugs, how long does it take for you to recover your systems? And lead time for change, how long does it take for you to, from the beginning of a user story until finishing of the user story? That really, it shows me that you are getting into a flow of delivering. I wanted to say value, but that's not true. You are delivering something, but you're still not sure if you are delivering value. These are more or less technical metrics. They are interesting, but they can lead to local optimizations, meaning your team gets very fast in delivering features, delivering code, delivering things, solving problems. But if business initiatives are unclear, you are still not sure if you are delivering value. So what can you do about making sure you deliver the right value? You can start thinking about goals, OKRs, KPIs, maybe a bit like the subject before from Diana about SLOs, making plans about or assumptions, hypotheses about what is going to deliver or what value am I going to deliver. If you look at the picture, what's your goal? Do you really want to shoot as many targets arrows as you want, or do you want to hit a target? And there are a lot of different levels of goals, but they should all serve the same purpose. So you should start from the top of the organization. What's your vision? What is your strategic goal? One of the things I like is evidence-based management. It has 3 levels of goals. The strategic goal, so that's more or less the mission statement of your organization or what you want to achieve in the coming 1 to a number of years. Then you have the intermediate goals. What are we going to do maybe in the first quarter or in the next 2 quarters? And then you have immediate goals. What are we going to deliver right now? And these goals should be measured. So you should know if you are going towards the actual goal. And to measure things, you can also think about OKRs, objectives and key results, or in another book, which I've mentioned at the sources, is Sooner, Safer, Happier. The author John Smart renames them to outcome and key results, because you are looking at the outcome. What is your desired outcome, and how do you know you are getting there? So for example, you have a strategic goal. Maybe at the end of this year, we want to be #1 vendor of a software system in, say, China. Then your intermediate goal might be, well, we start enhancing product quality. With this, we want our key result to be customer satisfaction should be 4 out of 5 and 15% less bugs. Then the immediate goal, maybe implement the customer feedback system, because otherwise I cannot reach my intermediate goal. I just don't know if my customers are satisfied. Another thing, work in progress. Work in progress also comes from lean manufacturing. Many people might be familiar with it, but there are not many teams that are really actually making or using work in progress limits. But work in progress limits make it very easy to identify inefficiencies and bottlenecks in your team workflow. So one of the workflows I really like is, for you as a team, just look at your backlog. And maybe you say, okay, the coming 2 weeks, we are with 4 developers. So we set our work in progress limit on 2, meaning only 2 user stories could be open at the same time. When a developer cannot help somebody else 2 stories are open, so there is a need for him to open a third one. He should pull the end cord figuratively. So not really pulling an end cord or pushing a button, but just tell your team, see, I cannot work because you are all working on these 2 stories and I need to open a new story. And then everybody, and I mean everybody from the team, should stop working, gather around and have a retrospective. What's happening? What's wrong with our flow? What is the bottleneck? Are our stories too complex? Or can we still split up a story we are already working on? Make changes. Can we improve our process? So some people are asking, but we do retrospectives every 2 weeks. Well, I think that's important, but it's even better to have a retrospective when something's wrong. So use the end cord. If something is wrong in your team, pull the end cord and have a retrospective at that point, because then you know what's the problem, what are the exact parameters of the problem, what's happening. And also, if you improve now, you can reap the benefits right now. Well, maybe you say we will fix it at our retrospective in 2 weeks' time. Well, maybe in 2 weeks' time you don't know what exactly happened, or you're too busy, or maybe you'll shift it to another sprint again. So in my opinion, use the work in progress as a start, just as I said. And another interesting thing, learning culture. A very interesting story, and that's why I'm using the image of these planes. In 1968, in the Vietnam War, the US Navy pilots were losing dogfights. I believe it was 2-1. Losing 2 out of 3 dogfights. I guess they were 17 pilots a day were shot down, something like that. And the problem was they just didn't have experienced fighters. They sent them to war, but they didn't have real war experience. So what they wanted to do is they wanted to slow down, take time to learn and get more experience out of the real war zone. Many of us know what happened then, because what happened is they established something called the Navy Fighter Weapons School, better known as Top Gun. Well, I'm not doing anything with Top Gun related at the work, but what we do is we do a lot of different things in where we can learn how to get better. Think about coding dojos, where we sit together with teams or with team members and do programming CAD tasks. Just try and get better on maybe subjects like test-driven development, refactoring, all kind of stuff that can really help getting better out of the normal day-to-day work. Code retreat, which is basically the same, but then you do a full day of programming out of work in a different area, but also more programming. So with the whole team working together on one story to quickly learn from each other and improve your process. Another thing I like to use is liberating structures. I'm going to show you another card desk I have here with a card desk with all the kind of liberating structures there are. Liberating structures are ways to collaborate together outside of the normal ways in which we meet. If you think about having a meeting or having a brainstorm session or having a presentation, most of the time it's like one-to-one or one-to-many communication, and there's not really everybody is involved. When you use things like liberating structures, you are really trying to involve everybody. For example, one of the most simple one is called a 1-to-4-all. With 1-to-4-all, you just ask a question like, how do you think we can solve this issue? Think about it yourself. And then in a pair of 2, then in 2 pairs of 4, you discuss the problem and then you discuss it with the group. So if you have somebody in your team that's always talking, if you have somebody in your team that never talks, by helping them in this way, you give them a better area to talk about problems. Also, a very good improvement of the psychological safety. And one of the last things, which I think is kind of funny, at the current work where I work, we do a full week. We call it the Willy Wortel week, and Willy Wortel is the Dutch name of Gary Geerloos, the inventor from Donald Duck. We do a full week of kind of research and development. Everybody can just pitch a project. People get together, work on this project. Other people get together, work on the other project. And for a full week, we are really trying to learn and get better. Very important for all these things I just said. Okay, the last part of the model is simplification, making problems easier to solve. And we are many times we are talking about getting the helicopter view or the big picture, but before you know, you get stuck in kind of a analysis paralysis because you are just making the problems more difficult by seeing the whole picture. You start overthinking. It can lead to overly complex systems. I'm not saying you should never look at the big picture, but make sure you also make things simpler to solve. One important subject when you talk about simplification is cognitive load. Cognitive load is the amount of resources you need to process information and to basically do your job. And many people, many teams, when you ask them about bottlenecks or problems, they will tell you that, well, we have so many meetings, we have so many disturbance, we just don't get into the flow because we don't have focus enough. All these things are about cognitive load. Many people will not tell you, well, my cognitive load is way too high, because that's a bit abstract, but a lot of signals will point to cognitive load. You can think about so many domains the team is responsible for, so many handovers, loss of focus, too many meetings, I already mentioned. But what is cognitive load? Well, it's a theory which says there are 3 types of cognitive load: intrinsic, extraneous, and germane. And they are all considering a different subject of cognitive load. The first one, intrinsic, is about actually solving the actual problem, the knowledge you need to process, and you have the knowledge already, but the complexity of the information and solving it. Extraneous is about the way how information is brought to you. For example, maybe your product owner explains you what to do, but you just don't know what he's saying. It's just very unclear. Then your extraneous load will get higher. So bad information from outside, unclear information, it increases the cognitive load. Then the germane is about deeply processing of new information. So you know something already, but you get new things. It's more or less thinking about how to solve a problem, not about solving it, but how to solve it. And you can do things to increase or decrease the cognitive load on all different areas by addressing them. Well, think about how you can, how these constraints can lead to a high cognitive load, and how they can improve your flow will really make your people happy also. And happy people, happy organization, happy customers. So one of the things you can do to decrease the cognitive load is work on the dependencies. Are teams depending on each other? Are they waiting for each other? Do they need information from each other? So work on the decoupling of your teams. Make sure they get more autonomous. If you have a lot of handovers, if you have a lot of waitings, it can also lead to tight coupling, which is also very difficult or very dangerous if that leaks into your software. So really look into dependencies. And a great way to do that is looking into team topologies. Team topologies is it is a book, but it's more or less a vision or a language which you can use to talk about how can we structure our organization or create an organization that's optimized for fast flow, for flow. And team topology said you only need 4 different types of teams, which are streamlined teams, enabling teams, complicated subsystem teams, and platform teams. And a streamlined team, the most important team of your organization or teams of your organization, where the value is being made. And a value stream team should be aligned should be aligned to a value stream of your organization. For example, if you have an organization that sells books online, maybe one of your value streams might be marketing. And in your value stream team, everybody regarding marketing should be involved, from your business people until your dev and operations people, and maybe even after marketing, stuff like that. The whole flow should be in that team. You have an enabling team. An enabling team has the task of the enabling team is helping streamlined teams to create value. So if they are stuck in any way, the enabling team should help them out. Complicated subsystem teams, think about machine learning or other difficult things that you are not doing on a day-to-day basis and on which you need experts. I already gave the example, machine learning, AI, things you need real experts of, and they are not really a streamlined team, but they will deliver some complicated services. Then a platform team, that's like the layer 2 organization. Think about cloud services, all kind of services that you need for your teams to deliver value to your customers. It's always also said you have 3 interaction modes. You work in collaboration, so you work together on a short amount of time, maybe to share knowledge or to learn from each other, and then you go in your normal mode again. You have X as a service, meaning my team has a service. Here you have the description on how to use it, and that's basically all the collaboration we need. You can use our services if you do this. And then the facilitating, that's the way the enabling team works many times, helping people, facilitating people in moving on, doing their job. And that being said, X as a service is the preferred way, because then you are not really coupled. People can deliver things autonomously, can use each other's services. And one other thing is architecture for fast flow. Think about using cloud, using using services on which people can, or teams can easily onboard themselves. Platform engineering. The state of DevOps is calling it flexible infrastructure, helping teams to be more autonomous in using the services they need. So, a quick recap of what I shared. I think it's a lot of information, a lot of tools, a lot of practices, but I hope you learned something today. I might not give you a solution to solve your problems, nor the problems of your organization, but I hope that at least you have an idea about how can we improve, what approaches are there which we can use by listening, by slowing down, by making things simpler, by implementing feedback loop, by being as agile as possible using an eclectic approach with all the tools, all the methods that can help to deliver your customers. And I want to stop the talk with this picture, because this shows some of the techniques I use, some of the methodologies I use. There are more. There might even be more that are not even here. But if you look at it, agile and lean startup in the middle, they are all about amplification, slowification, and simplification. But there are other subjects that are more or less in different areas. And I think it's good if you see problems in your organization, think about what can we need, what tools can we use to improve problems. And with that, I want to thank you all for listening. Thanks for having me once again. If you want to have a chat with me, or you have a question, or you want to provide some feedback, you can contact me. There are, let me just quickly show you, a lot of resources at the end, but if you scan the QR code, you will get at a page where all these links are also available. And thank you very much.
Hello again, Jacobs. Thank you so much for a talk.
Thank you.
So, but we have some questions from the audience. And as we have some time left, I would say let's tackle them right away. So, first question, how do you integrate team topologies into large organizations with complex hierarchies?
Oh, that's an interesting question. Well, I think the first thing is to acknowledge that the hierarchies are complex, and maybe that's where the problem also lies. But I think basically it starts with identifying your value streams. Where's your actual value coming from? Can you make clear boundaries between all these different value streams? Because it is about delivering value at the end of the day. So that, I think that's where you need to start identifying value streams. And there are a lot of tools like value stream mapping and other technologies which you can, or methodologies you can use. But that's where I would start.
Okay, thank you for this tip. Next question. What specific tools or techniques have you found effective for implementing DevOps principles within teams?
Well, that's interesting, because it sometimes feels difficult to really implement DevOps principles in teams, because there's so many. It's always a question, where do we start? I like to explain to teams what the DevOps metrics are, and then have a conversation, have a Gemba walk with a team. What is your biggest bottleneck for delivering? What is stopping you from really getting into a flow? And then look into, well, what is the biggest bottleneck? How can we make your problem simpler, or how can we improve your process? And well, it really depends on the problems of the teams. One of them I described, the work in process or work in progress. That's something I really love to start with teams. Just show them how much time they lose waiting on each other, and improving their workflow by just working on 1 or 2 stories at a time, finishing them quick, get feedback, and then improve. But it really depends. It depends on the team and on the people in the team. And of course,
Yeah, but numbers don't lie. Confront them with the time.
Yes.
Yeah, that's a very good point. All right. Thank you for sharing this, Jacob. And we jump to the next question. How do you balance speed and agility with security in DevOps?
Well, that's also a good question. Well, the thing is, I called my talk Fast Flow. The question is, do you really need to be fast? And what is fast? And you shouldn't be that fast that you are forgetting about stuff like security.
Yeah.
In fact, security is a big topic in the State of DevOps report, shifting left on security. So really make sure that your team understands that they also need to deliver secure software. But it's difficult, because many teams are already struggling in getting agile and delivering value, and security is a complex subject. So, well, as I said, I'm in an enabling team. So what I do is I get experts in my enabling team to help teams focus more on security. But it is a difficult subject, security.
Mm-hmm. Right. Thank you for that answer as well. Next question. How would you handle the cultural shift required for successful DevOps implementation, especially in an organization resistant to change?
Yeah, well, I believe that's maybe the most difficult question to answer, because change is very difficult, and especially as said, in an organization that's resistant to change, many times what you see is that managers or CEOs or the C-level management, they are operating in a way that they think they know what they're doing, and to change their mind is very difficult. So what I do is I do talks like this. I give them books once in a while, just try and show them some of my ideas, and hopefully that helps. And it does help, but not always. But you can do a lot of change from bottom up. If you implement the DORA metrics as a team, and you are really focusing on improving your team, and trying to ask questions like, why are we doing this? What is the value? They will tell you, but we don't know. Then ask them, why don't you know? Why should we work on it? Like, one of the interesting techniques of liberating structures is the 9 whys, just asking why 9 times. So just ask your product owner, why are we doing this? Well, I don't know. Why don't you know? And then maybe they are doing the same thing to an upper level. Just keep asking questions, why are we doing this? But it is hard. And sometimes people just don't want to change, or organizations. You're smiling, right?
Yes, I am smiling. Yes, no, your points are very valid. I just thought of asking again and again until they get angry with you.
Yeah, but
It
you
was the
know,
first thing that popped into my mind.
if they get angry, I think they get angry because they don't know the answers. So
Yeah.
maybe you can just tell them, I think you are getting angry because I'm not trying to do anything bad. I just don't understand why we are doing this.
Yes,
And it
yeah.
seems like you don't know too. That's not a problem, but let's talk about it. Let's investigate. Do we know we are delivering value? And if not, maybe we can create smaller feedback loops, stuff like that.
Yeah, that totally makes sense. Thank you also for that answer, Jacob. And we jump to the next question. How do you handle the scalability of DevOps practices as your organization expands or changes?
How do you handle the scalability of DevOps practices? Well, that's a very broad question, because about the scalability, that can be like the social part. How do you make sure that everybody that comes in new will keep up with what other teams are doing? Well, part of it is try to be involved in hiring people, because then you maybe can get the best, but that doesn't always work. So what always also helps is do community of practices, do a lot of different sessions with people to just keep up. Like for what I'm currently doing is I'm calling it tribes. Like we have an agile tribe, we have a scrum master tribe, we have a front end tribe. Try to keep continuously educating and keep learning together, do stuff, which is also fun. Like you also have a lot of fun, which is also good for your psychological safety. But keep people continuously improving. That's the best thing I can think of.
Okay, thank you, Jacob. Let's tackle the next question. What do you think are the most common challenges an organization can encounter when transitioning to DevOps? How to solve them?
The most common challenge. What I am seeing, you know, I work for a consultancy company and I have like 600 colleagues, and I have a lot of discussions with them. Many organizations seem to struggle with a widening gap between business and development. So business seems like they have all the ideas, they know what they are doing. Development teams, they just need to implement features and that's it. And many times it's just not true. The feedback loops are way too big. They are not delivering the right value, or they don't know what they are doing. I think that's one of the most common challenges. You know, if you have an organization, like if you have a real organization with value stream teams, you're really strongly working together with a very safe environment in which you can challenge each other. It's very different to say, well, we don't know what we are doing, or there's such a wide gap between business people. For example, in my organization, 2 years ago, many people were telling me business. And then I asked them a question, who is business? And it was like a black box. They didn't even know who business was. And one of the quotes I like from Sooner, Safer, Happier is you saying, there is no business. It's our business. We are working together. For example, Amazon doesn't have anything like business people and development people. They are an organization working together. It's very strange to have such a gap between them. I think that's the most common challenge.
Yeah, thank you for your insights on this as well, Jacob. We got another question. How can lean principles practically improve workflow within development and operations teams?
Well, lean is also a very broad subject. You could say that lean is kind of the predecessor of DevOps, or DevOps is highly influenced by lean and Toyota production system. Two tools I already used, but well, things like work in progress is coming from lean. That's really strong in creating better workflows. Well, I think they just can, just because they are about flow, they are about creating value, they are about fixing bottlenecks and fixing flow in your organization.
Okay, so just everything basically helps improving them. Yeah. Okay, makes sense to me. Thank you. So, next question. I understand the benefit of security and the role of DevOps in development in a large team. However, could DevOps be implemented in a team of 2 developers?
No, that's interesting, because if you look into the theory, what is a large team? There's something called Dunbar's number, and Dunbar's number is a number. Dunbar did research in how many people can you actually trust and work together at a time. And Dunbar is saying that you can trust 15 people at a time, but you can really deeply trust 6 people at a time, which is the Dunbar's number. So your team should actually never be larger than 6 or 7 people, because then you get trust issues, definitely. So that's my first thing about this question. If your team is larger than 6, well, maybe you should think about splitting things up or change something. But how can you implement DevOps in a team of 2 developers? I don't know if I would like to work in a team of 2 developers, but if I would, I could. But because why can't you do things like DevOps in a team of 2 people? You can just start pair programming the whole day. Maybe that's the best step to start. Do everything together. Don't work as a single developer. Do everything together and start from there, I guess.
Just build it up from the base, basically.
Yeah. You know, the thing is, what is implementing DevOps, right? You can implement. There's not really a handbook about this is DevOps. So use what works for your team and forget about things that do not work.
Yeah, it's so many things that comes from experience, I would say. All right.
Yes.
Good. Thank you, Jacob. We got another question. A DevOps engineer should know about the network security, such as router configurations, device configurations. Okay, maybe should a DevOps engineer, maybe it's the correct phrasing here. So how important is that?
But the thing is, I don't consider myself as a DevOps engineer. I see myself as a software engineer, more or less. So but maybe that's also why I like the approach of team topologies, because team topologies is like you are not really having a DevOps team in a sense of that you are doing all the operations. You have a platform team with highly skilled professional engineers that know way much about router configurations and device and all these kind of stuff, making sure, so that's like the layer 2 organization, making sure that the layer 1 organization can do their job. So for me, I wouldn't say I need to know everything as a DevOps engineer or as an engineer in a team, because I hope I can rely on people that know better. But it's a gray area. Of course, you need to know some things, but not all the details, I guess. That's impossible. You can't know everything about everything, right? That doesn't
That's
work.
true, yeah. The time that people are like universally specialized are long time gone since the ancient Greeks. All right, thank you, Jacob. Another question. What are some KPIs you think are useful for tracking the success of DevOps transformations?
Personally, I'm not really interested in tracking the success of a DevOps transformation. I am interested in metrics that show that we are delivering value. And if we are delivering value, then the next step might be I will look into the DevOps metrics, which I said. But counting how many teams are doing DevOps, that doesn't really make sense to me. They are successful in DevOps if they are delivering value many times a day, preferably. So maybe the DevOps metrics might be a start, but I think custom metrics about maybe customer satisfaction and things like that are more interesting for me.
Okay, thank you, Jacob. We have time for one more question. What role does automation play in your approach? How do you determine which processes to automate and what should be handled manually?
Well, we are still talking about DevOps, so I believe teams should have a mindset of automating as much as possible. And when you talk about improvements, things like the metrics again, if you want to do multiple deployments a day, you will definitely start automating things. But I'm not pushing them on doing that. I believe they should do that themselves. And if their metrics are showing that they are slow or their processes are faulty or a lot of things are going wrong, then maybe we can look together into maybe we should automate more. But I think also, again, the numbers will show that you are not automating enough, and we need to look into that.
Makes sense. All right, then, Jacob, thank you for the many answers in the Q&A. Thank you for the awesome talk you gave today. It was a very interesting topic. And I hopefully see you again on another live day.
Well, thank you very much, and thanks for having me. And have a nice day.
Thanks, Jacob. You too. Bye. Until next time.
Bye.
All right. And we jump to the final speaker of the day. He is Senior Customer Engineer at Microsoft, has a focus in DevOps, modern applications, containers, and also security. And apart from all of that, he's a father, an international speaker, an avid reader, a gamer, and in his own words, an all-around nerd. Very welcome, Chris.
How you doing?
Hi, Chris. I'm doing fine. Hope you are too.
Yeah, I'm excited to talk today about GitHub Actions. I was listening to the last speaker, and great questions, great answers. Really good topic.
Perfect. Yeah, you already mentioned your topic, but before we start with your talk, would you mind maybe sharing one or two sentences about what we are going to learn from you?
Yeah, I really like to kind of go through how GitHub Actions work, like zero to hero, just really understanding like how the processes get triggered and the steps. And I want to enable people that watch this to be able to go out and start making their own workflows and use GitHub for automation for building and releasing software, as well as other things, as you'll find out.
Perfect. Okay, very interested in what also these other things might be. And Chris, I would say without further ado, the stage is all yours.
Thank you very much. So, yep, today we're talking about CICD with GitHub Actions. My name is Chris Ayers. I am a senior customer engineer at Microsoft. I'm on all the socials, and I do have a blog out there. And I have a lot of repos and samples at GitHub, specifically like this repo as well. Pretty much all of my talks and all of my repos, the slides live in GitHub and the demos live in GitHub. I love speaking and sharing information with people. That's why, in addition to speaking, I also organize a conference. So I'm one of the lead organizers with a group of friends of DevOps Days Tampa Bay. So our CFP will be opening probably in a couple of months, but I just love talking about this stuff. So today we're going to start with YAML, just to level set everybody on what YAML is and some of the basic rules of that. We're going to go into CICD, and then we're just going to do demos, some high-level concepts on actions, and then we're just going to do demos and understand how actions work as we go through all of these different demos. And I have a link here, but I'll talk about it. A lot of lists or properties, lists start with a dash. Properties like key value pairs have a colon separating the key and the value, and then objects, you can name the object, and then you have a bunch of properties. So just to kind of show what that looks like, I have a dog. Her name is Zelda, and you can see I could just do key and value and get the thing out. I can say her favorite things, maybe a belly rub, or treats, or naps, things like that. And then, I can make this whole thing a property. Whoops. So the thing about YAML that will bite you a lot is indentation. Indentation, if you're off by a space, you get weird behavior. And this is the thing that bites people more than anything else. If you have like inconsistent spacing, like different things happen in the renderers. So if you're ever doing things in YAML and we start running into weird problems, check your indentation, check your spacing, make sure things line up properly. And the reason I start with YAML and just that level set on these rules is GitHub Actions and workflows are all written in YAML. So just making sure that we understand that some of those common gotchas just save so much trouble later. And when I talk about CICD, there's actually 2 CDs. And a lot of times when I talk about CI, it's continuous integration. We're going to do building. We're going to be doing unit tests. We might be doing some other automation tests, security scans, maybe a deployment to dev and UI testing. Cool. When we talk about CD, that might be it's on the train and it just goes all the way to production without a human in the way. And that might be continuous deployment. If it meets all of our definitions of quality, why not send it to prod? Sometimes people want to have some sort of manual intervention in a way. So we've enabled things for continuous delivery all the way to production, but we're not just always deploying. We have the like push button deployment methods, and maybe we're just doing some approvals, but the capabilities exist all through. And that brings me to actions. So actions help enable this. We can do CI, we can do CD, we can do so much more. These are YAML files that live in the .github workflows folder in your Git repo. So these are all YAML, and these are event driven. So if you've used any other CICD or automation type platform, there's like a trigger or an event that happens that makes your workflow run. I do a lot of education on Azure DevOps. And so in Azure DevOps, you have to say, I want a new pipeline, and it's this file here. With GitHub Actions, if the file exists in the .github workflows folder, it's going to try to run if it sees its trigger. So it's just creating a valid YAML file in that folder. It's going to try to trigger. And sometimes even if it's not valid, it'll trigger and complain. So just be aware, there's no registering or telling it I have a workflow. The file existing is enough. Now, there are a gajillion different events that trigger workflows. And when I said it does far beyond just CICD, here's why. We can trigger on all sorts of stuff, like you're trying to do things against branches, or somebody contributed to a discussion, somebody forked your repo, somebody left an issue. And so you can automate not just your development aspects, but you can also automate some of the project aspects. Someone has created a card or moved it to a column or done a pull request or pushed code or triggered a release. And then these 3 at the bottom, they're a little special: workflow call, workflow dispatch, and workflow run. With a lot of other systems, you can just manually trigger a job or a workflow or a run whenever you want. In Actions, you have to be explicit. And you have to say, I would like you to be able to manually trigger this workflow. So you need to do workflow dispatch. Workflow dispatch is how you do manual. The call and the run are how you do some sort of nesting. Like this workflow is going to call that workflow, or this workflow is going to run when that workflow runs. So there's a ton of events, and we're going to cover quite a few of them as we go with some real demos. I'm just laying the groundwork for the understanding of the concepts. And so, like I said, an event happens in the system, and that's going to trigger the workflow. And the workflow consists of jobs. It could be 1 or more jobs. And so when a job runs, it executes. And there's inside the job, there are steps and commands. These could be just a shell script, like I want to run a couple of Bash or PowerShell or Perl or Python commands, or they could be actions. And we're going to talk about where our actions are, how to find them, even how to write them. And so in the order of the job, there will be a series of steps defined. Those run in order from top to bottom. Step 1, step 2, step 3. And the entire job runs on a runner. And a runner is just like a virtual agent. It could be in a container. It could be on a VM. There's lots of options, and we're going to dive a little bit more into that. Now, you can have more than one job. You can have 2, 3, a large number of jobs. By default, if you don't say anything, the jobs run in parallel. So they will each try to spin up if you have a lot of parallel jobs. And so you need to sometimes enforce those dependencies. Like, I don't want my deploy job to run before I finish my build job. You need to wait, let the build and the test run first. Each job runs on its own runner. They don't have to be the same runner. Like, you don't have to pick Linux or Windows or Mac for each. One could be Linux, one could be Mac, whatever. So let's see a couple of jobs run just real quick, just to understand what we're talking about. Now, everything is in this repo. I'll put it in the chat and see if we can get that shared. But if you go to the .github folder, like I said, and workflows, here are all my workflows. And you can see I've got lots of updates to them. And if I want to see the runs, all the runs are here in Actions. So let's take a look at a very basic one and just kind of understand what's happening. So I'm going to just look at this one. And so we've got a name, and I've got here, this is another list syntax. I've got an array. So I've got 3 different events I'm going to trigger on. Push, pull request, and a workflow dispatch. So I can do that manual thing we talked about. And then I have a list of jobs. So this is where we have multiple jobs. And I'm going to define one job called build. And I'm going to say this runs on Ubuntu latest. So this is going to run on a Linux machine. And then I have some steps I'm going to do. And so there's this action, actions checkout. And I have a version on that. We're going to dive into that. And then I have just a hello world. And so if I want to see this run, if I want to understand what's happening, I can come here. And because I said workflow dispatch, I can actually say just run it right now. So I'm running it. And what's nice about the GitHub Actions interface is, yeah, you can see it's starting to spin up. It was queued. It renders out what it thinks the jobs look like. I get the commit hash of the current repo. I can link and see that workflow that's running. And then I can also dig into the individual jobs and see what's happening. So there's a setup job that happens, which has an operating system and a runner image. So we're going to come back to that because I want to talk a little bit about runners. And you can see it gets everything set up. It downloads an action. It runs that checkout action. And so it's syncing my repo. It's checking out all the code. And then it runs a script. So this was the command it ran, echo hello world, and it was using bash. And then I see the output of that script. And then it does some cleanup. So just running the things sequentially. Now, I'm not just going to write little shell scripts. I'm going to build code. I'm going to run Python. I'm going to build Java. I'm going to build .NET. So there's a link here, actually, that's awesome. So this is actually all of the runner images and all of the software included on the runner images. So out of the box, without me having to customize anything, what GitHub provides me is all sorts of different languages, runtimes, package managers. I've got Helm, I've got NPM, I've got pip, yarn. I've got tools, so I can do different things with like Ansible, and I can do Git and Packer. I've got CLIs for AWS and Azure and GitHub and OpenShift. And then it even tells me what the environment variables are for these different packages that I'm going to be leveraging if I wanted to do Selenium. So if I'm just not even worried about it, I just want to go build my software or run some things, there's a lot of provided capabilities out of the box so that I don't have to maintain these images and patch them. That's the big thing. When you're running your own image or you're running your own host, you have to patch and maintain these and keep these up to date. The other nice thing about the GitHub Actions, they cache some Docker images. So if I'm building images, I don't have to wait for the full image to pull. They've already cached a number of really popular image and items. So I can just go pretty quickly. Now, when I talk about actions, runners, there's a huge selection of them. In addition to Ubuntu, there's Mac, there's Windows. And essentially, this is just a small container. It's not really a full VM. You get like a small container. Every job, you have to think of it as starting with a fresh operating system or fresh file system. So if you want to share information between jobs, you need to do something to upload a result and download a result. And we'll talk about that. And so whatever changes you make during the run of your job, those get thrown away for the next job. Just something very important to keep aware of. They have, in addition to some of the standard size ones, they have large hosted runners. And so when I talk about runners, let's see what we're talking about. And I love the documentation. I'm a huge fan of it because it's really good about, getting you where you need to be and look at some of the options. So we can look at the supported runners and operating systems. And so you can see you're getting a certain amount of cores, you're getting a certain amount of space, a certain amount of memory for each of these images. And then they have some standard ones, they have some larger ones. And so you have options for building small projects or large projects, whatever you need. You can also install, like I said, your own VM, maintain it, your own container system. You can maintain it and tie it back. So let's just keep playing. Let's play some more. So we saw one. We saw one workflow. Let's look at the next workflow. I've got a couple here. Let's just work our way down the list. What if we wanted to see some additional options? We wanted to see, I only want to run on certain branches, or I want to include or exclude certain paths. I don't want this to run for the JavaScript files, or I do want to run on JavaScript, but not on .NET. I want to only trigger this workflows with tags, or I only want this to be pull requests into main, or I want to run it on a schedule. I give it a cron tag, so I can run it nightly, or I can run it every day or monthly. So you can lay out all sorts of different triggers, and you can have multiple triggers. Any of them will trigger the workflow. So you have a lot of capability to fine tune this to whatever system you want to use. Something else that I mentioned, and I just want to keep kind of digging into is, what about jobs? I said we can have one or more jobs. So I have job 1 that just says hello, and job 2 that says hello, and job 3. Like I said, when you start running these basic workflows and you have multiple jobs, they could run in any order. So let's wait for the UI to update, and we're going to go look at it when you have multiple jobs running. So you can see we got 3 jobs, and it rendered those jobs, and job 2 finished first and then 1. So we're not really controlling that order. So what we can do to build on that is we can start setting some dependencies in place. And the way dependencies work, it will actually change how the actions runner renders things as well. So if we set up dependencies, like I want job 1 to run and then job 2 and then job 3, it actually changes that rendering, and you can actually visually see that wait. And if we look at that workflow file, the way we introduce forced dependencies is job 2 needs job 1. So my deployment needs my build. My tests needs my build. So you can establish quite complex networks and graphs of dependencies if you need to. Maybe you want to deploy infrastructure as code while you're building your software, and then the actual deployment of the software depends on those two. So you have a lot of options. Let's just keep going for a second. And we're going to dive into steps. So we've kind of talked about triggers and runners. We've kind of talked about jobs and dependencies. Let's talk about these steps as we get a little deeper and a little deeper. So I can click on those jobs and I can actually see the individual actions while they're running. I get this live stream of logs. It's awesome. And let's look at what's happening here. So I actually have a couple of different jobs. Like in Bash, I'm saying echo $path. It dumps it out. CMD, I actually got an error. I told it to continue on errors. PWSH is the cross-platform PowerShell, and I'm using the PowerShell syntax for environment variables, $env:path. That works. It dumps out PowerShell. PowerShell spelled out, that's Windows only. So that's not working. But I can use Python as a shell. I could use Perl as a shell. So I can define my own shell. And let's look at what this workflow actually looked like. So I'm going to go back to the summary, and I'm going to look at the workflow steps. So we can specify, if we don't specify a shell, we're going to get a certain shell on Linux and a certain shell on Windows. But we can be explicit and specify what shell we want. We can say continue if it doesn't exist. We can do multi-line scripts. So if you do a pipe at the end of the run, it'll let you do multi-line scripts. So then you can do import, you can print, you can do whatever you'd like. And then if we look at this type of syntax, this is where we get into actions. So the top section gives us full capabilities to run whatever scripts we want or whatever language we want. But now as we dive into the awesome power of actions, it's really finding and reusing these chunks of actions that people have written. So we have, I can specify commit hash. So I can even lock myself to a very specific commit and version of an action. I can lock myself to a major version, a minor version, or even just a branch. But how do I know anything about checkout? How do I know anything about actions? GitHub is pretty good about that. So if I'm on GitHub, if I'm on any site, if I go up here to the top, there's the marketplace. And you might, there might be different ways for you to find the GitHub marketplace, but this is the marketplace. And we want to look at actions. And so there are a ton of actions, 21,000 actions that are both provided by organizations and provided by people. And as you can see, there is some sort of verification system by GitHub. It doesn't cost $8. As far as I know, these are actually verified things, not just paid for. And so, I work for Microsoft. I do a lot of Azure stuff. So if I look for Azure, here's an Azure login. Here's a web app or Kubernetes. So if I look at the Azure login, I can see versions. I can see the list of versions and the history of it. One important thing, if there is a GitHub action and it's in the marketplace, it has to be public. So it's a public repo. There's a link to it. You can go look and see how it's written, what's happening inside here. You can go look at all the source code. You can dive into, the implementation. You can go figure out, hey, how did they do that thing? You can go play around with it. You can file an issue if you want. You can, that's because I work there. So you can look at issues. You can look at pull requests. You can, report abuse. But what I love in most of them is the README loads into the marketplace. And so I can look at how I implement it, how I use it. I can get documentation on it. And then I can get under the samples, here's how I use it. And they'll usually give me very specific use cases on how I can trigger it, how I can use it, and samples. So going back to checkout, for instance, I can come down here and I can see here's my usage. And they have all these different parameters and stuff and inputs. Let's figure out how to mess with some of those inputs and variables. So like these are well documented, and I love that a lot of times they'll show stuff like this where it's like, I want to check out this thing. I want to check out that thing. I want to do this scenario. I want to do that scenario. It very much based on the actions author, but there's some really, really good use cases that will teach you quickly what to do. So let's look at variables real quick. And I'll run this guy. And we'll dive into variables. So we're running some scripts and we're doing some checkout. Let's actually just, let me go back and bring up the variables. So ENV is how you define environmental variables. And at the time I wrote this was really one of the only ways to get environment variables into the scripts. You can still do, you could do secrets at the time. They've expanded this quite a bit. And notice I'm defining some environments at the workflow level, and I can use it down at a single script inside of a job. So the environment variables persist down through the levels. And the reason I say this has changed recently is they did add repo level variables, and what we're going to touch on those. Those go a little bit beyond the environment variable. So this is that YAML object and then key value mapping we talked about. And then for Bash, this is how I reference my environment variable. Now, one of the really, really cool things I just want to show is you can define variables wherever you want. You can define variables at the workflow level. You can define some variables at the job level. You can define some variables at the step level. So you can do different things based upon context. So let's see what that looks like when we run it. So I'm just going to look at one that's already ran. So for this one, I had it says hello world from step. And if I go back and look at the second job, that says hello blank from workflow. And to see kind of why one is blank and one is defined. So I said hello from workflow. I said location job and world at step. And so step overrode job and overrode workflow. It's pretty much like the last in wins. If you're using the exact same environment name, like it'll initialize with that and then it'll get overridden. It'll initialize with that and then it'll get overridden. So that'll persist. The other thing to note here is I said name world on build 1. I didn't say anything on name 2. And this picked up greeting, but not name. And it was saying workflow because these things didn't get persisted into my other build, just to kind of show that some things are more independent. So you need to be aware if you're getting weird values, where you're defining them, where you're using them. Just trying to move along since we have a lot of cool stuff to cover. Conditionals, like you can do conditionals. You can do ifs. You can do like if this was successful, if the branch name is main, if the environment is production. So you can trigger if you want jobs or steps to run based on some conditional information. And as you can see from the syntax, this $brace, that lets us do some kinds of logic and programmability, expressions inside of our YAML. And there are actually quite a few expressions and things that we can do as we start diving into building more things. So if I look at expressions, we have some functions here. So like I want to do some formatting and I want to kind of do like a string print, or I want to do an ends with, or I want to see if something contains a string, or if an array contains a string, or if I can do JSON operations, from JSON to JSON. All of these are documented in GitHub. So if I look up GitHub expressions, here are expressions that we can evaluate, and it's very well documented. Like what are literals, like the string types. So you can explore these, like if you needed to do hex, or you needed to do greater than, or certain types of logic, what branch I'm on, or if I wanted to get some of those functions. So this is where you can come if you're trying to do an edge case or just trying to see if something works. It's well documented here. And I touched on it, but we're going to dive into it a little bit more. Contexts. So we saw that we were using. I'll just run it. We'll get into it. So the thing about context is when we're and we're going to come back to what a matrix is or different contexts. GitHub has a context in the middle of the runner. So think of it like the kind of the global value or singleton of what's happening with your run. You can see like what build you're on, what path you're on, what repo you're on. This if I look at the runner context, I can see the OS I'm running on and the name of it and my temp paths and stuff. For my given step, it'll tell me if it was good or bad and what the outcome was, and the same with the job. But when I start getting into the GitHub context, I start seeing information about forks and hooks and all the URLs and the paths and the status of things. And I can leverage that for different operations. There's, your token secret is in there. You can have other contexts like secrets and variables. And so understanding the context available and when to use them is super powerful. Those are all documented as well in the documentation. So, we've seen that, leveraging some of the environment stuff when we're doing like env context. But see, like GitHub event, I want to know if it was a pull request or not a pull request. I want to know various things around it, like the action that's currently running or the path or the repo. So all of that information about the running job, you can find out and you can operate with. And so, a lot of things you're going to find under settings, and, down here, you'll see actions, and this will include secrets and this will include variables. So if I set secrets, so these are environment secrets, these are like for a given environment, these are for my given repo. You can also have org level secrets in bigger organizations. Same with variables. You can define variables for environments, which I'll touch on, but I mean, that's something like, I want to call it prod or something. And then you can have repo level variables that maybe you're just using for various things. And there are some cases you can do org level secrets and variables. So let me go back down here and we'll just see what that looks like real quick. So I'm going to look at this guy. So this is where, I have my environment variable for the workflow, but I can pull it in a vars dot. So I'm using the expression syntax. I'm using the vars context to get some sort of environment variable. And I'm using that to define a job name. I'm checking if condition happens. I'm using that to define a runner name. I'm outputting things from an org level or a repo level. So I can do some interesting things with those. And one thing I do love is VS Code. And VS Code has a bunch of extensions, including one on GitHub Actions. So this is showing all of the workflows it's detected, like the one I just showed you. It's going to show me the individual runs for each workflow. It's going to show me the workflows and the runs for each one currently in place, but it's also going to let me look at my environments, my secrets, and my variables. So some of those variables we just looked at, I can see right here, and I can edit from Visual Studio Code, and those will actually go up, and then I can run this workflow, and it will use that new value. So using the extensions in VS Code is a good way to, trigger workflows, monitor workflows, see runs that are happening. So it's 7B. When it runs so quickly. You can see I can link right to the run that happened and just see information from it. So cool, powerful techniques that you can play with. All right, let's just keep moving on a little bit. Secrets. Now, secrets definitely has some stuff I want to talk about. GitHub's usually very good about protecting what might be outputted or not outputted on the screen. So if you've marked something as a secret, so you have hello, but I'm gonna reference a secret's name. It knows that that name is coming from the context of secrets. So it will show a command line, but it will try to star out the name. Another option is to say, I want to output on the command line 2 environment variables and then pass in that as an environment variable. So you can do it that way. One thing to really, really be aware of with secrets is it's a little bad at breaking up structured data. So if you pass a structured thing and it gets reformatted a little differently, the regex or the matcher might not detect it. It might output things. And if you parse the JSON and then output an individual thing from it, it's really bad. And so you might have secrets exposed in your logs if you're not careful, if you're outputting them or if you're invoking them in certain ways. So that's something just to be very aware of, like how you pass secrets to actions or other workflows. If you want to do it via a command line, if you want to do it during variables, via context. So, that is, I've actually put the secret on the command line, and it's doing its best job to hide everything. Here, I'm just saying, hey, I have two things. I'm gonna pass them in as environment variables, and then you can see it's doing a little bit of a good job hiding those. But let's say I had an object that had, client secret and endpoints and stuff. I invoked it on the command line. It sees these all as individual lines, and so things don't get masks like it should. What if I try passing it as an environment variable? So now it's a little bit smarter and it's hiding some of that information. But if I then parse out, a single client secret out of that, it's not smart enough to know that this one field should be protected. So when you're working with secrets, be careful of those things. Now let's just build some stuff. Let's one example that is awesome from working with Node is maybe you're doing an npm package and you want to have it work across multiple versions of Node. You can set some defaults on a working directory. You can do path and branch filters, like don't run unless it's on this path. But I want to do this strategy. I want to do this matrix strategy. I want to make sure this library works on Node 12, 14, and 16 for both Windows and Linux. And so we can define a matrix strategy. And for each property under the matrix strategy, we can have an array of values. We can have more than just 2 or 3. But what we're going to get is 3 versions times 2 OSs. We're going to probably have 6 runs of this. And notice we're using the expression syntax and we're using the context syntax. So we're referencing the matrix properties. And so when this thing runs, it will do a matrix. It'll spin up all of these 6 times. And we're going to have 2, choices here between Windows or Linux. And so that'll be the runs on. And then we're going to use node version blah. And then we're just going to do our npm run and test like we normally would. And so this is awesome for validation against a wide range of targets. If you have a lot of different configs, and they have some really good documentation on, as you can see, we've got 12, 14, and 16 Ubuntu and Windows. And we can see the individual jobs and how they're going and all of that. If we look at the matrix build, what I really like is you can add specific things. So you can do this normal scenario, and then you can include or exclude individual settings. So it's really neat, the high level of customization and capability you have with that. And so we can make sure that all of these just run on the correct version of 12. Yep. Everything looks great. GitHub Actions is agnostic. It really doesn't care what you're trying to build. It just gives you the tools to do what you want. My slides are Markdown slides. They're to a system called MARP. And so whenever I check in Markdown slides and images, this runs, makes a folder, copies some images and themes over, and then runs a Docker client against that folder. And then it uploads it to GitHub Pages. So you can interact with pretty much whatever language or system you want to work with. For .NET, I do some some different things. I want to do a build step, or maybe I do some test and validation, and then I want to do a deploy step. And so I need to be able to pass information from one job to another. Notice I'm still doing some of the defaults just to limit where I run. And I'll come back to this permissions ID token. I'll come back to that. But I'm going to check out my code. I'm going to use .NET 8 because .NET 6 is expiring at the end of the year and .NET 7 expires in May. So we should be working our way towards 8. Caching. So there's this cool package that Actions provides, and to help cache. If you have really large projects where you're pulling in lots of NuGet or npm packages, you can set up caching up, and it's very well documented. Big fan of this. So if I go Actions cache, here's our Actions cache, and we can look at it on the marketplace instead of just their repo. What I love about this is, let's say we want to just come down here to the usage. So they have strategies and use cases for pretty much every language and package manager out there. It's awesome. So if I want to do some Yarn stuff, here's how I would use it in Yarn to check for caching and restoring. So super awesome stuff. But then for .NET, I'm going to do my restore. I'm going to do a build. I'm going to do my tests. I'm going to publish it to a temp folder, and then I'm going to use upload artifact. So I'm just going to say, hey, take this folder and upload it kind of as a zip file named web app. And then I'm going to do the same for infrastructure as code. That's my job, but that's the whole job. Now for a lot of demos, I might not know the names of my web app I'm going to spin up. I delete it between talks and then I spin it up again. So I also need to communicate and get stuff between steps in addition to jobs. So I'm going to download my infrastructure as code from my previous step. I'm using the same name, but then I can tell it whatever folder I want it to go in. And then I'm going to log into Azure. Notice I'm using that expressions and secrets. And I know what to pass because I read the documentation on the Azure login task in action. And now I'm deploying a bicep file with a secret and an app name. So I don't know what the app name is. I can just kind of give it a suffix or something. And bicep you deploy just like you do ARM. And so then I'm going to download my web app and I'm going to say, I don't know what the app name is, but the app name is the output of that deploy step. And the way I can figure some of this out is, this is in my steps. I need the deploy step. So if I ever want to reference a task or a job from a previous run, I need to give it an ID. So ID deploy is going to let me do steps deploy. And my bicep, I had an output called web app name. And so that automatically gets added as an environment variable, and I can kind of reference it and deploy it. So there's actually, and I'll show you a link to the documentation on that. But let's see this run, and we'll speed up for one or two last things and open it up for questions, because I'm sure there's lots of questions. One thing I love about the power of GitHub Actions is they don't just do like PRs. They give you triggers for stuff like PR open, PR closed. So that lets you do some really interesting things, like creating an environment when somebody does a PR and then destroying it when they're done. So that whole job ran. That was very quick. That took us 17 seconds. So now it's going to deploy and it's waiting on my approval. So one way I can do approvals is I kind of mentioned it. I can go make environments. So I can have environments for prod, for dev, and each environment can have their own secrets. They can also let me do, there's required reviewers. I can do protection rules. I can set environment secrets and variables. So I can have ways of approving and reviewing things. That's where that manual intervention comes in before we deploy. They're definitely getting more rules in place, but for a time, really approvals was the only way. Some people will use stages with tags and labels, like you have to tag or label a PR in order for it to go someplace. There's lots of options, whatever your workflow for your organization is, or whatever you choose to pick. And just in order to save time, so that we can make room for everybody in their questions, I want to talk about just linter real quick. So there is a super linter that GitHub puts out, which is awesome. You can just invoke it, and that will like lint and clean your code. And so I wanted to show off, well, what about if I wanted to reuse that capability? I want to have some sort of linting capability and use it over and over again. Well, you can make your own kind of reusable workflows. So you can say this has, instead of those normal triggers, when you push, when you do a PR, this is only on workflow call. So I have this job where I'm going to lint my bicep. And so this is a reusable linting step for me that I can invoke from other workflows. So if I want to go to like my PR validation run, this will generate a resource group name based upon my PR. So the PR underscore GitHub event number. So that'll be like the PR number. And this is gonna happen on pull request. And this is going to use that workflow that you just saw. So I don't have to have those lint steps in every single one of my repos. I can leverage it and reuse it. Reusable. Helps if you type right. So there's a whole section here on doing reusable workflows and creating them. So with that on workflow call, having inputs and access to secrets through those and being able to call those in different ways. The documentation is very good, very effective, and they have some good samples to use. So definitely check them out if you have questions about that. The other thing you can do is you can make your own action. There's the idea of composite actions, but I'm a big fan of the reusable workflows. And what this will do, like I said, we'll create an environment for our PR. We can go look at it and make sure it looks good. And then when I'm done, I close my PR, and this workflow will only happen when I close a PR. It'll find that same resource group again, and it'll delete it. It'll clean up all my stuff. Now, a lot of the things I've been working with are around triggers with the code base, but GitHub has taken all of those things that we talked about where you could do forking or issues or comments, and they actually made a training platform out of it. And skills.github.com. If you would like to play with some of these things, come and play with some of these things directly, including writing your own actions or publishing packets. So, like, if I want to do this, the way I interact with this, I look at the README, and starting course is really just forking it. It's forking it, and then what's going to happen is, and as I can see in my GitHub workflow step, when it gets invoked, there'll be one like, oh, on fork, like they have all sorts of different scripts that are going to happen and trigger, and they built a training platform out of it. It's really, really cool. Now, when I'm interacting locally, like I don't want to have to push and wait over and over again for things. I can actually use Actos or Nectos Act, which is really cool, to invoke workflows locally. So this uses a Docker container, and it has a lot of the same tools, but I can invoke like individual workflows if I want. I can test out things to validate stuff is working, and I can validate those locally. It's really neat. So it's called Act by Nextos. And I mentioned a bunch of the security stuff. Don't use structured data. make sure you're using secrets in that secret thing. Check them out regularly. I use actions instead of inline scripts a lot. OpenID Connect. So I mentioned I'd circle back to it, so I just want to hit that real quick. Well, I used to, when I was originally logging into different clouds, I would just deploy. You'd have a credential, you'd have a password, service principal stuff in your environments, and you would log into the cloud and do your deployments. That's still something someone could steal. I use OpenID Connect now. This is like the recommended way to deploy to different clouds, where GitHub has a trust with like Azure and AWS. And this is where I was having that permission token, ID token right. It's because when the workflow triggers, GitHub Actions is going to send a token to Azure. Now you have to make like an identity there and a workload federation in Azure, but the documents are all off of Azure login or AWS login. They'll tell you how, but it's going to say something like, you're coming from this organization, from this repo, from this environment, from this branch. And that can be how you can identify your specific identity. And it can be a very secure way of locking, this is my product identity, this is my non-product identity. I also love Dependabot. Dependabot uses actions. You can tell it to scan not only your NuGet and your NPM, but you can tell it to scan your GitHub Actions. So if I don't know if you noticed in my workflows earlier that there's some PRs that I closed, and some of them were from Dependabot, where it's saying you should really increase your actions from A to B. So they can automatically keep you up to date on your versions of your packages and of your actions. It's really cool. I highly recommend it. And with that, questions. I'm sure there's a couple in the chat, and I wanted to leave some time for that. And then here's some resources for everybody while we do questions.
Hi, Chris. Thanks for the talk. Yep, we got some questions in. You're totally right. First, quick question from my side. You named your dog Zelda? Or was this just an example?
Yes, she's actually sleeping behind me. And I have two kittens. One is named Link. So we've and we have another dog named Xena and another kitten named Bean.
Very likable, Chris. Awesome. All right. Now that this is out of the way, my questions, we can tackle the attendee questions.
Great.
All right. So first one. Will these actions be integrated into MS DevOps pipelines in the near future?
So GitHub Actions are open source, and they're very specific to the GitHub environment and workflow. Now, on Azure DevOps, there's both the classic build and release pipelines that exist, and now there's also YAML pipelines. And YAML pipelines follow a very similar structure and syntax to GitHub Action workflows. Just like with everything, you can do pretty much identical things on both sides. I feel there are some things that are a little bit easier or better to do in Azure DevOps. There's some things that are easier to do in GitHub Actions, and you get some additional capabilities in Actions. They're two separate products. They're two separate things. There is, for those interested, there is a tool called GitHub Enterprise Importer that helps people move from DevOps to GitHub, but DevOps isn't going anywhere. GitHub isn't going anywhere. I think they kind of target two different parts of the industry.
They're coexisting.
They do. And I mean, if you've tried doing some really strict Agile or Scrum processes, it is a lot easier in a lot of cases in DevOps. But the GitHub Actions and, well, their projects and boards are definitely making leaps and bounds. Some of the controls and security controls that exist in DevOps are pretty powerful. They did recently add GitHub Advanced Security for Azure DevOps. That's a thing, so that you can do some of that high-level SAST scanning of your code. And there's also Defender for DevOps, which is for both GitHub and Azure DevOps, that'll kind of surface your security stuff and scanning into like Defender for Cloud, but that's a whole different topic.
Right. Thanks, Chris. We got another question. How do you handle versioning of artifacts in CI/CD deployments?
Yeah. So that's actually an interesting question with different scenarios. So, like for container imaging, like there's some very good tagging guidance out there for if you want like stable tags, like a V1, a V2, something like that, versus like hash-based tag and very unique tags. With websites and packages that you're doing releases for, I use semantic versioning, and there's some really good tools out there to help you with semantic versioning. When I'm doing continuous deployments of websites and things, a lot of times the specific version doesn't matter to me so much. So I'll just use the build ID, the build number, the run number, because when I use one long workflow that has a build and an artifact and a release, those are all tied together. So if I redo the deployment, it's going to redeploy the right version of that thing. Like if I just deployed something and it was a bad build somehow, it made it through my tests, it made it through my level of quality, and I really something got out and the website's acting up or the infrastructure's bad, I would just go to a previous run of that pipeline and redeploy that stage, because it does keep the artifacts around for a while, or I can rerun it at that hash and just rebuild it to that exact, where everything was at that point in time. Which is why package locks and things like that are very important, so that you can have deterministic builds where possible. And the bill material, so you know what went into building it. I hope that answers the question.
Yep. Some very good tips. Thanks for that, Chris. So, next question. Is it possible to gather various information with a GitHub action and then render a README file, either by referencing it somehow or creating a new one and then committing?
Yeah, you can do all sorts of stuff. If you can do it on a command line, you can do stuff. So yeah, in the middle of a workflow, you can do a commit. Now, what you might want to do is put some conditional logic there so that you're not causing a commit or action storm where your commit triggers a commit, which triggers a commit, which triggers a commit. So that's where maybe using a branch or a tag or something like that to limit if it gets triggered again happens. You'll notice in the skills.github.com, it will do commits. It'll copy files, like the workflow in those that skills. When you do a comment on a PR or you do a thing, it will overwrite the README and make a new commit, and like it'll tell you wait 15 or 20 seconds and refresh the page, and then the README will change with new instructions. So it's quite possible to do that.
All right, thank you, Chris. And we move on to the next question. How does IAC work together with GitHub Actions to simplify deployment processes?
So I'm a huge fan of infrastructure as code. I love Terraform, I love Bicep, and I do talks on them all the time. The big power of modern infrastructure as code tools compared to what we used to do decades ago, where we had scripts that would say, if this exists, cool. If not, go create it and do this thing. And then like, we don't need to do that. We really try to be declarative today, which just says, I want an environment that looks like blah. And so idempotency says, if the environment already looks like blah, I don't have to do anything. And so in a lot of my applications, I have a shared service or a Bedrock type of deployment that might be that hub spoke model for the cloud, or a shared firewall or something. But for my given application, I'll have infrastructure as code for the specific needs of that application. And every single time I build and deploy my app, I deploy the infrastructure as code. I build and test my my software, and then I deploy it out and maybe run acceptance tests. Because maybe my application needs changed, and so I added code for Redis, and I needed to update my infrastructure as code for Redis. They go together. If I rolled back and I didn't need Redis anymore, I wouldn't need the code for Redis. Like, the state of the application and the architecture of the application are intricately coupled and tied to the application itself. And so I just deploy those every time, and it's usually a no-op if you've written it right. Trial and error, test.
Test, yeah.
I when I'm first building new pipelines or new workflows or new vertical slices of things, of empty app, infrastructure, deploy it out. It might take me 15 or 20 times to get it right the first time, but then I have a template that I can reuse and stamp out.
Great. Yeah. Thank you for clarifying this as well, Chris. And next question. Do matrix builds improve testing and deployment efficiency in GitHub Actions?
I think it improves efficiency definitely for library authors. I mean, if you're trying to test different configurations, you don't want to, if you're doing the exact same steps for every OS or for every version, and really the only difference is that version or that thing, and you just want to make sure it works for people, instead of copying and pasting these workflows over and over again and having to tweak them time after time, if it's really just, I'm going to use a matrix strategy, test these versions, go, I think it's a huge efficiency. And it's just a template language. So it's still going to make 3 jobs or 6 jobs, and they're going to run like jobs independently in parallel. So it just saves me time.
Perfect. Happy to hear that. All right. Thank you, Chris. And we move on to the next question. What's your attempt to troubleshoot failed builds or deployments in GitHub Actions?
Read the logs. So if I look at status failed, so some of these you'll see there's some failed ones, but I can just come in here and go, oh, this script failed, and it's because I already deleted it. So like I can read through and run it. A lot of times the problems I'm going to face when I'm first doing it are usually path based. Like I would say path based are the biggest issues. Like did I and they'll expire after a while, but did I do the / properly? When I downloaded the artifact from the previous job, did I reference the path right? If I am trying to reference a job, did I pass it the right information? Do I need to tweak the values? So that's where when I'm first using a new task or I'm first doing a new activity, it might take me 15 or 20 times. And then once I'm done with that, like I now have an exemplar, but I always say if you're not in double digits, then you got it too easy.
All right. Good. Thanks for this tip as well. Next question. What security measures are in place to protect my sensitive data, in GitHub Actions workflows?
Yeah, I mean, they do all sorts of security on push protection, security hardening. They have guides on it. I think there's all sorts of encryption that happens with things. They try to protect it. So I would just review the security guides and security hardening because they do have some recommendations. But as far as I know, like I think of a lot of the secrets that I'm leveraging in GitHub Actions, like a key vault. I do try to limit where I store secrets everywhere. A lot of times it'll just be, I need a connection out to something like a secure key vault, or I need a connection out to an app config. That way, as I'm deploying things and I'm using Bicep to create resources and managed identities, I can not worry about having as many secrets. Like that's ideally the goal, right? If you're using a managed identity, like specifically in Azure, I know, but there's something similar in other clouds where Service A can talk to the database, can talk to this, talk to OpenAI, and those have some sort of RBAC rules that allow the different resources to talk. I don't need secrets. Really, I just need configuration. What are the endpoints?
Okay. Thank you for this answer as well. And we got one more question, Chris.
Sure. Yeah.
Why did Chris recommend Ubuntu images for the GitHub Actions? It is large in size, and most of the time, runners doesn't need multiple programming languages at the same time for small jobs.
So out of the choices on GitHub, so there are, and again, if you're just using GitHub hosted runners, there's a couple of choices. So there are Ubuntu, Windows, and Mac. Like those are your three. Like really. So you get Ubuntu, you get Windows, you get Mac. There's also a multiplier on cost. So like Linux and Windows cost about the same. Mac costs like 5 or 10 times as much for the same amount of runtime. And so you're not caring about spinning up images. This is not you pulling down and running an Ubuntu image on your machine. This is GitHub itself doing the hosted images. And typically Ubuntu and Linux are going to spin up quicker and complete faster than the Windows and Mac runners. And they give you, so if we look at the billing, so the bill rates for the Linux ones,
okay,
so 2-core, 8 cents, 2-core, 16. So Windows is twice as much as Linux. And in Mac, I don't know if you can see, there's some extra zeros. Like that is a significant difference there. So, and whether or not you're like, well, it doesn't have the languages I need or what I think it's super impressive what is available on the images. Like there's just a ton of available, let me go back to this one and setup job, and there's just so much on the images. And if it's not the language you're looking for, cool. You can install whatever language or thing you want. But if you're trying to do Kotlin or Julia or Fortran, they got you covered. Ruby and Swift and Python, they got you covered. Java and .NET, like the complaint that they don't have a lot of languages, I think is a little misleading. But you can install whatever you want. You can do whatever you want. And if you want to run an image on your own machine, you can run your own image. You can install your own stuff. You can install the agent and boom, pick what you want. But
pick your poison.
But for ease of use, and I don't have to think about it, Ubuntu latest go.
Yeah, makes totally sense to me. All right, Chris. Then with that, thank you so much for all the answers to the Q&A, and thank you for the talk. It was a very interesting topic, if I might say. And so it's I think it's quite early at your place, so I hope you have a nice day. A nice start.
Thank you very much.
And many greetings to Link and Zelda. Some belly rubs. Right. Chris, until next time. Bye.
Bye.
All right. And now that also this live day comes to an end, thanks to our partners who make events like this possible. You can scroll down on the live page and just click their logos and look at what they are offering. Also, we have a bonus talk from Dan Ares today. Also, just scroll down. We have some, it's just a section called bonus where we can watch his recorded video, and we have 2 more videos from past live events of ours listed. And now that also the day is over, you can feel free to go to code100.dev because next stop for our coding competition is Amsterdam on February 29th. So if you're in the area or just curious and also want to see Amsterdam maybe one time, check it out. And I hope we all see each other on the next live day on February 21st, when it's all about Python. Till then, bye.